Window functions, or sometimes we call them analytical functions. They are very important functions in SQL. Everyone must know them, especially if you are doing data analysis. Each time I write SQL script in order to do data analytics, I end up using them. So as usual, we're gonna go and now understand the concept behind them, and then we're gonna start practicing. So let's go. Okay guys, so now let's start with the first question. What are SQL window functions? They are functions that allows you to do calculations like aggregations, but on top of subset of data without losing the level of details of the rows. So it is something very similar to the group by, but here we have special case. You don't lose the level of details. So now in order to understand the definition, let's have a very simple example. Okay, so now let's understand how SQL works with the group by clause. Let's say that we have the very simple example. We have 4 orders, 2 orders for the caps and 2 orders for the gloves. And let's say that I would like to see the total sales for each product. So now if we decided to use the group by, what SQL gonna do? Gonna take the first 2 orders for the caps and put it in one row. So in the output, we're gonna have only one row for the caps with the total sales of 40. And the same thing gonna happen for the gloves. So we're gonna take the 2 rows of the gloves from the input, and in the output, we're gonna have only one row for the gloves. So that means the number of rows is gonna be depending on the number of products we have on our data. We have 2 products, we get 2 rows. So that means SQL is really like smashing or squeezing the results in the output. And this is exactly what the group by does to our data. It aggregates the rows, aggregate the data into different level of details. So now on the left side, we see 4 rows. On the right side, we have 2 rows, and with that we are losing some details in the results, but still we have solved the tasks. So now let's see what's gonna happen if you use a window function in SQL. Okay, so now we have the same data and as well the same task. We have to find the total sales for each product. Now if you use a window function, SQL gonna do the following. It's gonna go and execute each rows individually from each others. So what's gonna happen? It start with the first row, the order ID 1. In the output, we're gonna get as well the same stuff, the order ID 1, the same row, but we will get the total sales for the caps. So here the total sales is gonna be 10 plus 30, we will get 40. Then it's gonna jump to the second row and it's gonna process it as well. So in the output, we will get the order ID 2, the product caps, and as well we have the same aggregations since we are talking about the same product. So we will get 40. Then it's gonna go to the third order, and here we have the gloves. So in the output, again, we have the order ID 3, the product gloves, and the total sales this time gonna be 5 plus 20, so we'll get 25. Then it goes to the last row, to the order ID number 4. In the output, we're gonna get 4 gloves and as well 25. So now we can notice that if you use the window function, you will not lose the level of details of your data. So we are doing something called row level calculations. So if in input data we have 4 orders, in the output we're gonna get 4 orders, and as well we will get our aggregations correctly. So now if you compare both of the methods side by side, we can see that we are solving the same task. So we are finding the total sales for each product, but with the group by, we are smashing, squeezing the results from 4 orders into 2 rows, 1 row for each order. So that means with the group by, the granularity is changing, right? In the input, the order ID is controlling the level of details, but in the output of the group by, the product is controlling the level of details. So we have different granularity. But in the other hand, in the window functions, we are still able to do aggregations, but we are not losing the level of details. So the granularity of the input gonna be the same like the output in the results. So this is exactly the main difference between the group by and the window function. If you want just to do simple aggregations, then go with the group by. But if you care about the level of details and you need to add more details to your results, then you can go with the window function where you can do aggregations plus having more details. And now if you go and compare the functions between the window and the group by, we can find that both of them has exactly the same functions for the aggregations. So we have the count, sum, average, min, max. And here comes another difference between the window and the group by. The group by has only the aggregate functions, so that's it. But in the window functions, we have way more functions to use for analytics. So for example, we have the ranking functions, and we have here another group of functions for the value, or we call it analytical functions. So that means in the SQL window, we have a lot of functions. We can cover a lot of analytical use cases and advanced complex stuff. But with the group by, we have only the aggregate functions, only for simple use cases. So this is another difference between the group by and the window. Group by, use it if you have simple analysis, simple aggregations. Window functions, we're going to use it for more advanced data analysis where we're going to cover a lot of use cases. Alright guys, so now we're going to have a few tasks in order to understand one thing. Why do we need SQL window functions, and why in some scenarios group by is not enough and we have to use SQL window functions. So let's go. Alright, so let's start with very simple task. It's gonna say find the total sales across all orders. So we need one value, the total sales. Let's see how we can do that. First, make sure that you are using the database. So use sales database in case you have closed the clients, so that we don't get any errors. So now we're gonna start with the first thing. We're gonna go and select the sales. You're gonna find it in the table sales orders. So now let's just query the data, and as you can see we have 10 orders with 10 sales. We didn't aggregate anything yet, so we have the raw data now. So now in order to solve the task, we're gonna use the function sum. So sum of sales, and we're gonna give it new name, total sales. We don't have to use any group by because we don't have to group up anything. So that's it. Let's go and execute that. And as you can see, SQL gonna return one value, 380. This is the total sales that we have inside our data, and this is the highest level of aggregations. So with that, we have solved the task. We have the total sales across all orders. We don't have to group up anything. Let's move to the next example. Let's say that in the next task, this time we want to find the total sales, but for each product. So not for the all orders. For each product, we want to find the total sales. So this time we don't need only one value, we need one value for each product. In order to do that, now we're gonna go and use the group by function, and we're gonna group up by the product ID. And group up needs as well the dimension in the selection. So I'm gonna do it like this. So that's it. Let's go and execute the query. Now, as you can see in the results, we don't have one value. We don't have the highest aggregations. This time we are drilling down to the next level of details. So the level of details here is the product ID. We have one row for each product. So for the first product, we have 140, the next one 105, and so on. So as you can see, we are now splitting the data at the level of product ID. And we went from 10 orders. Now in the results we have 4 orders, and that's because we have 4 products. So the number of rows at the output gonna be defined by the dimension, the product ID. And with that, we have solved the task. We have the total sales for each product. All right, guys, so let's keep progressing in our examples. Now, the next one gonna be a little bit advanced, where we have the same aggregation, find the total sales for each product, additionally provide details such order ID and the order date. So now, as you can see, we have already solved the first part. We are finding the total sales for each product. Now we just have to add some additional informations like the order ID and the order date. So let's go over here and just add it in our select. So order ID, and let's have the order date. So let's go and execute that. Just gonna make it a little bit bigger. So let's go. But now, as you can see, SQL will not be happy, gonna throw an error and says the stuff that you are adding to your select are not included in the group by. So as you can see in the group by, we have only one dimension or one field called the product ID, but in our selection we have 3 dimensions: the order ID, the order date, and the product ID. So there is no matching between the select and group by, and SQL will not allow it. And now you might say, you know what, let's add everything to the group by. So with that, we're gonna get our aggregation, and as well we're gonna get our details. So let's try that. I'm just gonna zoom out a little bit, and instead of having the product ID, let's add everything. So the order ID, order date, and the product ID. So now we have matching, and SQL should not throw any error. Let's go and execute it. So now let's check whether we have solved the task. The task has 2 parts, right? We have to do the aggregations and to provide details. So as you can see, we have solved the second part. We have the details, order ID and order date, but now the first part, finding the total sales for each product, is destroyed because if you check the results, we have the product ID 101. It has the total sales of 10, but in the third order, we have it as a 20 for the same product. So actually the data is not aggregated, and that's because we are aggregating at different levels, and we have included way more stuff that we don't need for the aggregations. We are aggregating at the order ID level. So as you can see now, we are hitting the limits of group by. We cannot provide aggregations and as well provide additional informations from our data. You have to pick one. That's why we have to go to the second option, where we can use the window functions. So let's do that. I'm just gonna get rid of the group by part and as well all the fields. Let's back to the root. So now we have the sum of sales, and if execute this, I'm going to get one value. So we are at the highest level of aggregations. So now we need to use the window function. I'm just going to remove the name, and now we're going to tell SQL this is a window functions. Using over after the aggregations or the functions tells SQL we are talking about window functions. So let's just execute it like this, and with that we got 10 rows, and that's because we have 10 orders, and for each row we have exactly the same value. So we have the total sales of all orders for each row. So as you can see, SQL understands this is a window function, and SQL should not like group all the data in one row. It should keep exactly the same rows or same number of rows like the input. So with that we have the window function, but we have to split the data by the products. So now we're going to use the keyword partition by. It's like the group by but another wording. Products ID, the same dimension. So with that we have the total sales by products as a name. So let's go and execute this. So now as you can see in the output, we still have the same number of rows. We have 10 orders, we have 10 rows, but the result did change because now we are aggregating the data at the level of product ID. In order to understand the results, we have to add more informations to our select. So now let's add the same dimension. It's going to be the product ID. I'm just going to add it at the front over here. So let's select, and as you can see, now it makes more sense. We have those products and they have always the exact same sales, and as well for the next product and so on. And now here comes the magic of the window function. We can add more information to our select statement without having any errors. So now we need additional information like the order ID. So we can go over here and say order ID, order date, any type of column, you can add it to your select, and let's go and execute. So as you can see, now we got the result, even though that those 3 dimensions in the select are not part of the window aggregation. So with that, we have solved the tasks. We have additional informations, we have the order ID, the order date, and as well the first part of the task to find the total sales for each product. So each of those values are the total sales for each product, and with that we have solved the tasks. And this is exactly why we need window functions. In real projects, things get really complicated. You are doing different tasks in one query. So you are doing aggregations, you are doing some other stuff. So just focusing on the aggregations is not going to be enough. You have always to add additional information to your query. So as you can see, we use group by to do simple analysis, but as things get complicated in the analytics, we use the window functions in order to show the aggregations and as well add additional informations. So as you can see, we use group by to do simple analysis, but as things get complicated in the analytics, we use the window functions in order to show the aggregations and as well add additional informations. Alright everyone, so now we're gonna go and deep dive into the syntax of the SQL window functions. We're gonna cover everything, each part of the syntax, for you to understand how to use them. So let's go. Alright, so let's start first by understanding the basic components or the basic parts of each window syntax. Mainly we have 2 parts. The first part gonna be the window function. We have like sum, average, and so on. The second main part is going to be the over clause. And inside the over clause, we have 3 different parts. The first one is going to be the partition clause, the second order clause, and the last one we have the frame clause. And those are all components that you can use inside the window function. So 2 main parts, window function and the over clause, and inside the over we have partition, order, and frame. Let's go more in details. So for example, we have the following window function. So as you can see, we have a lot of stuff going on here. We're gonna understand them step by step, component by component. Let's start from the left. From the first one. So what do we have over here? We have a function, window function. So what is a window function? Like here we have the average. It's like any other function in SQL. You can use it in order to do calculations on top of the window. So the first thing to do or to define in a window is to define the function of the window. And as we learned before, we have a long list of many window functions available in SQL, and we group them into 3 groups. The first one, we have the aggregate functions. So we have the count, sum, average, max, min. All those functions, we have them as well for the group by. So those are used for the aggregations. The second group of functions, we have the ranking functions. So we have the row number, rank, NTILE, and so on. So we can use those groups in order to give a rank for our data. The last group, we call it value or sometimes analytics functions. So here we have very important functions like the lead, lag, first value, and the last value in order to access a specific value. And of course, we're going to go and learn all of them one by one, understanding the concepts, some examples, and as well for you to understand when to use them for data analysis. Alright, so now let's keep moving, understanding the other parts of the window syntax. Now, inside the function average, we have here a field name or column name called sales. This called a function expression. It's like a value, a parameter or argument that we can pass it to the function. And here we can use multiple different stuff. For example, depend of the function, of course. So here it could be empty, like here in the ranking, it doesn't allow to use an expression, so it should be always empty. Or we can use a column, like in the example, we use the sales. So we use the column name as an argument or an expression. For the average, we are finding the average of sales, or we could use a number. So here in the NTILE, we are allowed only to use numbers. Or we could have multiple stuff. For example, in the lead, we can have sales, then numbers, and so on. So things get complicated, don't worry about it. I'm going to explain that. So here we have multiple stuff, or we can have a whole conditional logic. So for example, here we have the case when, so on, inside the sum. So the whole thing over here called an expression for the sum. So as you can see, we can build here a complex logic, and the output of this logic can be passed to the function sum. So that means as an expression for the function, we can use different stuff. Of course, depends whether the function allows it or not. Alright, so now let's have a quick overview in order to understand which data types are allowed in the expressions for those functions. Let's see the aggregate functions. As you can see, the count function accepts any data type, but the others like the sum, average, min, max, they allow only numerical data types. Alright, so now let's move to the rank function. The expressions, it's really pretty easy. It should be empty. It doesn't allow any argument or anything inside those functions. So as you can see, all of them are empty, but only one that accepts numerical values, which is the NTILE. You have to define a numeric value. And now moving on to the last type, we have the value functions. They accept any data types inside the expressions. So as you can see, each function has its own specifications, and you have to be careful which data type you are using in the expressions. Okay, so now let's keep moving to the next one. We have a very important part in the window syntax. So far, what do we have? We have a function, we have an expression. It's like usual stuff. We have done that before using the group by. Now we have to tell SQL that we are dealing with the window function. It's not a normal one. In order to do that, we have to specify the keyword over. So the second main part in the syntax is the over clause, and we use it in order to define a window. And inside it we can define multiple stuff like the partition by, the order by, the frame, but all those stuff are optional. We can skip it and leave it empty. So the main task of the over, it tells first SQL we are dealing with the window function here, and as well you can use it in order to define a window of your data. So now we're going to go and cover everything inside the over clause, and we're going to start with the first one, the partition by. Alright, so now we're going to learn how to define a window inside the over clause. The first part that we can define is the partition by. So for example, here we have partition by category. We have to define the dimension. It's very similar to the group by, another wording. So the first part is going to be the partition clause. What it's going to do, it's going to divide the entire data sets into groups, or you can call it windows partitions. So here we tell SQL how to divide our data. And here we have two options. Let me just show you. So if we don't use anything, so we have it empty, you see over and partition by is not used, what can happen? SQL gonna use the entire data in order to do the calculations. So the whole data, the entire data gonna be counted as one window. So we are telling SQL, don't divide anything, leave it as it is. The second option that we have is to divide the data by partition by. So we define the window like this, partition by products, for example. So SQL gonna go and divide the entire data into different windows. For example, here, 2 windows. And here this time the calculation, the sum of sales, will not apply on the entire data set. This time it's going to be applied on the different windows individually. So we're going to find the sum of sales for window 1 separately from the total sales of window 2. Alright, so now we have this very simple example. We have here 3 fields, the month, product, sales. They are really easy informations. And now we have the following SQL window function. So we have sum of sales And inside the over clause, we are not using anything. So we are not using partition by. So how is SQL gonna define the window now? SQL gonna say, okay, I don't have to divide anything. The entire data set is one window. So SQL gonna go over here and say, the whole thing is one window. So there is no partitions, there is nothing. We have only one window. So the entire data gonna be aggregated. So this is what happens if you don't use partition by and you leave the over clause empty. The entire data is one window. All right, so now let's move to the next example. We don't want to have only one window. We would like to have multiple windows. So we have to divide the data by something. So in the over clause, we're gonna define the window like the following: partition by month. So it's not empty. We are now dividing the data by the field month. So the values inside this column gonna divide the data sets. So here we have 2 months, January and February. So what's gonna do, SQL gonna go and divide the data into 2 sets. The first window gonna be this one of January. So we have the first window, gonna make it smaller. And the second window gonna be the February. So it's gonna be 2 windows inside our data, and the calculation gonna be happening on each window separately. So here, as you can see, we are using the month in order to divide our data sets into 2 windows, one window for the January and another window for the February. So now let's have a quick overview about the options that we have with the partition by. The first option, as we learned, we can just skip it. So without partition by, for example here, total sales across all rows, and here we don't define anything inside the SQL. The second option, we can use one field, one column, for example, partition by product. So we are using one dimension, but we can go and mix stuff. We can use multiple columns or multiple dimensions in the partition by. For example here, partition by product and order status. So here with the partition by, we can define a list of dimensions that could be used in order to divide our data. So in this example, we are saying find the total sales for each combination of products and order status. So those are the different options on how to work with the partition by. So now let's have this overview again. For all functions, the partition by for all those functions is optional. So if you don't use the partition by in all those functions, you will not get any errors. So now let's go back to SQL in order to start practicing with this clause. Okay, so now we have the following task: find the total sales across all orders, and we have to provide additional informations like the order ID and the order date. So let's go and solve it step by step. First, I would like to provide the details. So I'm going to select the order ID and the order dates from the table sales orders. And next we're going to work with the aggregations. So we need to find the total sales across all orders. Again, since we have here details and aggregations, we cannot use group by, we have to use the window function. So we're going to go use the function sum for sales, and now we have to tell SQL we are working with window functions. That's why we're going to use the over clause. And now the next step, we have to think about defining the window. So let's check the task. It says total sales across all orders. So that means we don't have to partition or divide the data sets into like chunks or partitions. We have to leave it as it is, like the whole data gonna be one window. And that's why we don't use partition by inside the definition. We're gonna leave it empty. Let's go now and give it a name. It's gonna be the total sales. Let's go and execute this. And now as the results, as you can see, we have all the orders, all the details, and as well we have the total sales across all orders. So with that, we have solved the tasks. We have the total sales and as well some details about the order. All right, so now let's move to the next task. It's going to be very similar. So it says find the total sales for each product, and we have to provide additional informations like the order ID and the order date. So it's going to be very similar task, but this time we have to divide the entire data into windows. And that's going to be by the product, since we are saying total sales for each product. So this time we have to go and divide the data. So we're going to define the window like this, partition by, and we can use the dimension product ID. Let's go and execute this. So now you can see in the total sales, we don't have anymore the total sales of the whole data, but they are divided. But in order to understand the results, let's go and include the product ID in the results. So product ID and execute. So now by looking to the results, you can see that the data is divided into 4 windows. Let's see them. It's going to be by the product ID. So this dimension going to be controlling the partition. So the first window going to be the product ID 101. So we have the total sales for this product 140, and the next window going to be 102, the third one 104, and the last window it's going to be only one row, the 105, and the total sales of 60. So with that, we have solved the task. We have the total sales for each product, and as well we have some details. Now I would like to show you the dynamic of the window function. We can add multiple aggregations on multiple levels. Let me show you what I mean. Let's say we stay with the same example, but we're gonna find the total sales across all orders and as well the total sales for each product. So what we can do the window functions on different levels by, for example, here removing the whole definition. So here we have the total sales for the entire data for the first task, and the next one gonna be the total sales but divided by the product ID. Let's here rename it by product. Let's go and execute this. And now, you know what, I'm gonna go and add the sales as well, just to explain the flexibility of the window function. So let's go add the sales and execute it again. And now by looking to the results, you can see we have the sales informations 3 times, but with different granularities. The first sales, the sales itself without any aggregations, it is the highest level of details of the sales, and we're gonna have the sales for each order. The next one, the total sales with the window function, here we have the highest level of aggregation. So we have the total sales of all orders. And the last one, the total sales by product, it's something like in the middle. We are aggregating on a window, and the window gonna be the product ID. So as you can see, we have different granularities of the aggregations, and this is exactly the flexibility that we have with the window function. We can do all those stuff in one query. Okay, so now let's keep moving and adding stuff to our task. It's gonna say find the total sales for each combination of the products and the order status. So this time we have to divide the data not only by the product, but as well with another dimension, the order status. So now let's see how we can do that. I'm gonna just show the dimension order status and the results, and we're gonna add the following thing. So sum sales over, since it's a window function, and let's go now and define the window partition by. So we have again the product ID, but not only this dimension, as well the order status, and let's go and call it sales by products and status. Let me just rename those stuff. Okay, so let's go and execute. All right, so now let's check the results. It is the last aggregation over here, and as you can see here, the aggregation has different granularities as the previous one, and we have more details. This time we are splitting the data by 2 dimensions. So the first window gonna be the product ID with the order status. It's gonna be only those 2 rows. So we have the order ID 101 and the order status delivered. So the total sales of this gonna be 10 plus 20, and we're gonna have 30. The next window gonna be the same product but with different status. So it's gonna be the 101 shipped, and we're gonna go and summarize those 2 values, and we're gonna have 110. The next product and order status gonna be the 102, and we have it only once. So 102 delivered, it's only once, so it's gonna be the same value. The next partition or window, it's gonna be 2 rows, 102 with the shipped, it's gonna be those 2 things, 60 plus 15, we're gonna get 75. So as you can see here, the product ID and the order status, they are controlling how many windows we're gonna get. So we get here around like 6 windows. With the product ID, we got only 4 windows, and without using anything inside the over clause, we will get only 1 window. So this is how the partition by works. Alright, so that was the first part of the window definition within the over clause. Let's move to the next part. We have the order by. For example, we can use order by, order date. It's just a field. So the order clause is very important in order to sort your data within a window. So the order by is very important as well for many functions. So by just checking the overview over here, for the aggregate functions, it is optional. So you could just leave it or add it. But for the rank function and as well for the value functions, they are a must. So if you want to use those functions, you must use the order clause. because it makes no sense, for example, if you are ranking the data without sorting your data first. Okay guys, so now back to our very simple example, and we have the following query. So the function this time gonna be rank, so we have to rank the data, and the definition of the window gonna be partition by month. So that means we divide the data by the months, so we have it over here, and then the second part gonna be order by sales descending. So we have to sort each window by descending order. That means we start with the highest value and we end up by the lowest value. So let's see how SQL gonna go and execute this. So first, partition by month. So it's gonna divide the data into two partitions because we have two values by the month. So let's see how this is gonna look like. So one window for January and another window for February. Alright, so now SQL gonna go to the second part and execute order by sales descending. So what's gonna happen, SQL gonna go for each window separately and start sorting the data from the highest to the lowest without checking the other window. So in those three values, the highest one is this one. So it's gonna be on top. Let me just sort it. This is gonna be the lowest, you're gonna be in the middle. So SQL gonna sort this window separately from the next one. And then once it's done, it's gonna go to the second one. So the highest value gonna be this one, you are the lowest. Let me just do it like this. So SQL gonna sort it like this. The highest one is 70, the next one is 40, and the last one is 5. So with that, SQL done with the definition of the window. So it's splitted by the month and each window is sorted by the sales. The next step, SQL gonna go and rank those values. So it's really simple. In the outputs, it's gonna rank the data like this. So the first one gonna be this value, the next one gonna be 2, and the third one gonna be 3. So as you can see, SQL is sorting only this window, and it's gonna go and repeat the same stuff for the second window. So each rank is separately from the others. So as you can see, it's very simple. This is how SQL executes partition by together with the order by for the rank function. Alright, so now let's have a quick task for the order by. It says rank each order based on their sales from the highest to the lowest. And we have to provide additional informations like order ID and order date. So let's see how we can write the query. So we have the basic stuff, order ID, order date, and the sales. And now we're going to go and rank the data using window function. So we're going to use the function rank, and then we're going to tell SQL this is a window function, and inside it we have now to provide the definition of the window. So now by checking the task, you can see that we don't have to divide the data, so we don't have to use partition by, we have just to use rank, and with rank we have to use the order by, it is must. So we're going to use order by, the field going to be the sales, and from the highest to the lowest. So let's just call it rank sales, and let's go and execute this. And as you can see, our results going to be sorted from the highest to the lowest. So you can see the sales 90 at the top, and the lowest going to be the 10. And as well, we have a rank. So for the top rank, it's going to be 1, and the lowest rank going to be 10. So as you can see, we just quickly create a rank in SQL. It's very simple. The whole thing is one window since we are not using partition by. And of course, if you want to have ascending, so from the lowest to the highest, you can just remove it because optionally going to be ascending. So let's go and execute the query. So now we can see the orders are sorted the way around. So we start with the lowest and end up with the highest. And of course, you're going to get the same results if you go over here and add ascending. So if we execute, you see we got exactly the same results. So this is how you use the order by inside the window definition. Okay guys, so with that you have covered the second part of the window definition. Now we're gonna go to the last part, to the most advanced part of window. And we have the following stuff. So we have rows unbounded preceding. We call this a frame clause or window frame. So what we are doing over here is that we are defining a subset of rows within each window that is relevant for the calculation. Totally understand if this is confusing at the start or complex. It was for me as well. So what we're going to do, we're going to deep dive into the concept in order to understand how this works, and we're going to do it step by step. So don't worry about it. All right, so now let's understand what is going on with the frame clause from the basics. So now if you do aggregations and you don't use window function, you're going to consider the entire data or rows inside the table. But what we can do, we can go and divide the data using partition by to a window. So for example, here we have window 1 and window 2. Now if you go and do aggregations, all the rows in the window 1 going to be aggregated, and then SQL going to go to the window 2 and aggregate all the rows. What we can do in SQL is that we can say, you know what, I don't want all rows inside the window, I want a subset of rows inside the window. So what we are doing over here is that we have those two windows, but we specify a scope, or we specify subset of data from each window to be involved in the aggregations. And of course, not only aggregations, we can do ranking and other stuff, so I mean calculations. So here, like, we have a window inside a window. So we are defining a scope of rows. Not all rows should be involved in the calculation, but only a specific subset of data. And we can do that using the frame clause. So now again, the partition by, you can use it in order to divide the entire datasets into multiple windows. And now for the frame clause, if you don't want to consider all the rows within each window in the calculation, you want to focus and specify only a subset of data within each window, then you can go and use the frame clause. Alright, so now let's go and understand the syntax of the frame clause. Let's have the following example. We are saying the window function is the average of sales, and then we define the window. So we have the first part, partition by categories, order by order dates, and then we have the frame clause. It's going to be the following: rows between current row and unbounded preceding. This is the frame types, and we have two types. We have the rows and groups. Then we have like between and a range. So the first range going to be the frame boundary, the lower value, and here it accepts three types of keywords, like the current row, or a number of preceding, or the unbounded preceding. And then we have another frame boundary. It's going to be the higher values, and it accepts the following stuff. We can use the current row, in following, or unbounded following. So as you can see, we are defining like boundary or a range from low value to high value. So now we have some rules. We cannot use the frame clause without order by. So order by must be exist in the definition in order to use frame clause. And the second rule, it says lower boundary must be before the higher boundary. So always we start with the lower boundary and we end up having the higher boundary. You cannot switch that. Okay, so now we have a very simple example. We have the month and the sales and the following query. Sum of sales, this is the window function, and the definition of the window going to be order by month. We are not using partition by just in order to make our life easier. And the frame clause is going to be defined like this: rows between current row and the two following. So now let's see how SQL can execute this. The first definition, order by month, as you can see, the months are sorted already. So now SQL gonna work with the frame definition, current row, and the two following. So SQL gonna process this row by row. So it's gonna start with the first row, and it's gonna be our current row, as here in the SQL. So this is our current row, and we say the range until two rows, two following rows. So it's gonna be February and March. So that means the pointer gonna be over here for the two following. So with us, we have the frame boundaries, and SQL have the following scope for the first row. So we have 3 rows, and the summarization of those 3 rows gonna be around 70. So we will get for the first row 70 because the scope is not all rows, but only this subset of data. Okay, so with that, SQL is done with the first row. It's going to jump to the second row. So the pointer going to be the current row at the February, and the second 2 following going to be at April. So with that, as you can see, we are sliding down in the subset of data or in the window. And with that, we have a new scope, a new subset, and the summarization of all those values going to be 45. So that's it. I think you got it already. SQL going to go to the next one. The pointer going to be on March, and the 2 following going to be on June. And it's going to slide like this. We have those 3 rows in the scope, and the summarization of that is going to be 105. So now things get interesting for the next row. So the pointer for the current row gonna be April, but the 2 following gonna be like after the end of the table or something like that. So as we slide down, as you can see, the scope now, or the subset of the frame, gonna be only 2 rows, and the output gonna be 75. And finally, if you go to the last row, it's gonna be the current row, and we're gonna have only 1 row for this subset because the 2 following is just outside of the table. And we're gonna get the same value as the summarization. So as you can see, that's it. It's very simple, right? So the frame, we use it in order to scope which rows are involved in the calculations. So all what you have to do is to define the boundaries of the frame, the lower and the upper boundary. Let's see what other options do we have with the frames. Okay, so here we have the same example, but we redefine the boundaries of the frame like this. Rows between current row, this is the first boundary, and unbounded following. This means that we are targeting always the last record in the window or in the table. So unbounded following gonna be always static, and it's gonna be, in this example, pointing to June. And now SQL gonna go row by row, and the current row gonna be like the start January and then February. I'm just gonna take this example. The pointer is on February, and the subsets or the frame gonna be those 4 rows. So it's gonna be February, March, April, June. So it's gonna be 4 rows, and the total aggregation of that's gonna be 115. So you can do it like this, and previously it was like flexible, more flexible. It was 2 following, but this time we have unbounded following. That means always the boundary gonna be the last one. So as we are moving with the records over here, the boundary is gonna be smaller, smaller, and like this. And the last one, they're gonna be both in the same record. So the current record gonna be as well the unbounded following. Okay, let's see the next one. The definition of the window gonna be the following: rows between one preceding and the current row. So here it's the way around. One preceding is lower than the current row. So let's see how SQL gonna execute this. Let's say that we are currently at March. So this is the current row, and we are saying between one preceding. So that means one row before the current row. So the frame gonna be like this. And we have only 2 rows, so the value gonna be the summarization of those 2 rows, and it's gonna be 40. So that means we are always targeting the rows before the current row. Okay, so now let's keep going with the other options in order to understand everything about the frame. So we redefine it like this: rows between unbounded preceding and the current row. So unbounded preceding gonna be the first row in the table or in the window. So it's gonna be static like this. It's gonna be the first one, January. And let's say that we are at this current row in March, so the window or the subset gonna look like this, though 3 rows, and the total of that's gonna be 60. So now as SQL is proceeding to the next one, it's gonna fix the first boundary, so it's gonna be always pointing to January, and the subset gonna be a little bit bigger until we reach the last one, and with that we're gonna have the subsets, the whole rows. So with that we get a really great flexibility on how to define the subset and how the subset is shifting through the window. Okay, so now we are just having fun, so we are just playing around with the boundaries. We don't have always to use the current row. So we can use, for example, here in this definition, rows between one preceding and one following. So we don't include at all the current row in the boundaries. So let's say again, our current row gonna be in March. So one preceding gonna be February, and one following gonna be April. So with that, our frame gonna be those 3 rows, and let me get it like this, and the aggregation of this gonna be around 45. So with that, as you can see, the boundary is gonna be one preceding and one following, so it should not be always the current row. All right, so now I think you already get it. What's gonna be the last option? We're gonna have everything. So the definition of the frame gonna be rows between unbounded preceding and unbounded following. What we're gonna have over here, the unbounded preceding gonna be January, and the unbounded following gonna be June. And now the frame gonna be everything, all the rows, and it doesn't matter where are we with the current row, it's gonna be always a fixed subsets, so it's going to be always everything. So if we are over here or February or March, we're going to be considering all rows, and the total sales of that's going to be 135. So we will get the exact same result for everything for all rows. So with that, I think it's not that complicated, right? We just have to provide the boundaries, and then the calculation going to be depending on the frame, on the subset of data. Okay guys, so now let's go back to SQL and start practicing in order to understand how the frame work. So let's go and define a window like this. So sum of sales, and the window definition like this. We're gonna divide the data by order status, and let's say we're gonna sort it by order date. And let's define a frame like this: rows between current row and 2 following. Let's give it a name, total sales. So let's go and execute it. So now let's look to the data. You see that SQL gonna divide our result into 2 sections, 2 windows, delivered and shipped. And you can see that the data is sorted by the order date. So as you can see over here, for example, on this status delivered, we can see that 1st of January, 10, and so on. And then the third part, we have defined a frame in each window. So for example, let's take the first one. So this is the current row. So we say the frame is between the current row and the 2 following orders. So that means the scope gonna be like this. So 10 plus 20, 25, it's gonna be 55. And now what is interesting as well to check here is the last record of each window. So now let's take this window over here, and the last record gonna be number 7. So this order, and let's say this is the current record. So we said the frame between current record and the 2 following. But since it is the last record of this window, it will not go and consider the next 2 orders because those 2 orders are outside of the window. And that's why we have here 30, and SQL didn't go and summarize all those values. So we have it 30 and there is nothing after that. That's why we will get 30. So as you can see, the frame going to be calculated within one window. So it will not consider anything outside of the window. So this is how the frame works within partitions. So now I would like to show you as well a few stuff about the frames. We can use shortcuts, but we can use them only with the preceding. So for example, let's say I'm going to change the definition like this to precedings and current row. So let's go and execute it and we will get those results. So now if you want to check the results quickly, let's take, for example, this order over here, and we are always summarizing the values of the 2 previous orders. So that means those 3 orders going to be involved in the frame and the output going to be 55. So now there is a shortcut for SQL, but only for the preceding, where we can remove the range. So we can go and remove everything and we can leave it like this. Rows to preceding, and if we go and execute it, we will get exact results. So this is a quick way or a shortcut on how to define a window, but it only works with the preceding. So for example, if I go over here and say, for example, unbounded, it's gonna work. So we will get the results between the unbounded preceding and the current row. But if you go over here and you say, you know what, let's have the unbounded following, SQL gonna say there is an error. And the same thing if you remove the unbounded, let's say for example 1 following, SQL will not like it. So you can use the shortcut only with the preceding. And one last thing about the frames is that there is a default frame. So if you don't use any frame and you use order by, what can happen, SQL gonna use a default frame. So if you check the result, you will notice that for this window over here, those values are not like the whole values of the cells. There is like frame, there is a hidden frame. And the default frame in SQL gonna be like this: rows between unbounded, preceding, and current row. So this is the default frame if you use order by. So now if you go and just execute it, you will see that we will get the exact results. So be careful, once you use order by with the aggregate functions, there will be a hidden frame or a default frame like this between the unbounded preceding and the current row. So that means there are 3 ways in order to do this scenario of framework between unbounded preceding and current row. Either write it like this, or you can go and have a shortcut like this. Let me just execute it. So we'll get the same result, or just remove it completely. We will get as well the same results. Now again, the hidden frame or the default frame is only working with the order by. So if you go, for example, here and remove the order by, let's see the results, the whole window will be aggregated. So again, let me just select it. So you can see that SQL gonna consider all the rows in the aggregations, and we will get the total sales for the whole window. So there will be no frame defined. Only it's going to be present once you use order by. Alright friends, so with the frame clause we have now covered all the components on how to define a window inside an over clause, and with that we have covered everything about the syntax of the window functions. Okay guys, so now we're gonna go and understand the rules, or let's say the limitations of window functions. So let's learn what you are not allowed to do while using window functions. Okay, so the first rule is that you are allowed to use the window function only in the select clause and as well in the order by clause. So here we have again the same example where we're finding the total sales by the order status. So as you can see, we used the window function in the select clause and we didn't get any error, right? So now we can go and use it as well in the order by. So let's say order by, and let's go and copy everything but not the name in the order by. So if I go and execute this, there will be no errors and SQL can allow it. And as you can see, the result didn't change. So let's go and sort it, for example, descending. So I'm gonna write here descending, and let's execute. Now we have the total sales with the highest values, then the lowest values. So having this rule that we can use it only in select and order by, that means we cannot use window functions in order to filter data. So let me show you. For example, instead of order by, let's have where clause, where the total sales, let's say bigger than 100. So let's go and execute this. And as you can see, SQL gonna say, no, you are not allowed to do that. You can do that only for select and order by. So we are not allowed to use it for filtering data using the where clause. And as well, you are not allowed to use it in the group by. So if I go and do a group by, and as well remove the condition over here, so if you execute it, you're going to get the same error. You are not allowed to use the window function in the group by, so only with the order by, or as well in the select clause. Okay, so now to the second rule, you cannot use window functions inside another window function. So that means you cannot go and nest window functions together. Let me show you what I mean with that. So let's remove the group by. Now everything should be working. Let's take and copy the whole window function over here, and let's just nest it. So instead of sales, we're gonna have now window function inside another window function. So as you can see, this is the inner window function, and the rest, the outside, is the outside window function. So if I go and execute this, you will see that SQL gonna tell us you cannot use the window function in the context of another window function. So we cannot do nesting using window functions. So as you can see, this is another limitation for those functions. All right, moving to the third rule, or let's say an info. The window function can be executed after filtering the data with the where clause. Let's have an example. So now let's say that I would like to have the same informations, the total sales for each status, but only for two products, 101 and 102. So let's go and do that. So we're going to use the where clause, and then we're going to say product ID in, we're going to specify 101 and 102. So let's go and execute this. Now you can see we still have two partitions. So one for the delivered and one for the shipped, but the total sales is reduced because we are only focusing on two products and we filtered the whole data sets. So how SQL works, first the where clause is going to be executed, and then the window function is going to be calculated. So that means first filtering and then aggregations. Okay guys, now we're going to move to the last rule, to the most interesting one, and it says the following. You are allowed to use the window function together with the group by clause only if you use the same columns. So let me explain what do I mean, but first some coffee. Let's have the following task, and it says rank the customers based on their total sales. So now it sounds really easy, but if you check it, you have here two calculations. The first one, you have to rank the customers, and the second calculation is an aggregation. You have to find the total sales for each customers. Okay, so now I'm going to show you step by step how I usually solve those tasks. So for now, let's check the total sales. It is an aggregation, right? So we can use the sum function, and this function is available in both group by and as well in the window function. So for now, I'm going to go with the group by, and that's because the task is very simple. We don't have to show any other details, right? So it's all about aggregations. So why not using the group by? And now to the first part where we have to rank the customers, we cannot use the rank function with a group by, right? Group by uses only aggregations. So here we are forced to use the window function. So that means for the rank, I'm going to use window function. For the total sales, I'm going to use a group by. So now let's do it step by step. So first we have to find the total sales for each customer using group by. It's very simple. So I'm just going to remove all those stuff in our select statements. We need the customer ID. And then we don't need a window function over here. And then after the from, we're going to have a group by customer ID. So now I'm just grouping the customers and finding the sum of all sales. Let's go and execute this. So now as you can see in the results, we have 4 customers, and that's why we have 4 rows, and as well we have the total sales. So let's say the half of the tasks is already solved, right? Now what is missing with us? We need the rank. So let's go and build that. The second step, we're going to use the rank function, and we're going to define a window for that. So over, and inside it will not partition the data at all because it's already like grouped up. So what we're going to do, over order by, the rank function always needs an order by. Don't worry about it, we can talk about it later. So now we are ranking the data based on the total sales. That means the sum of sales. So what we're going to do, let's just go and copy this and put it after the order by. And now we have to decide whether ascending or descending. It's going to be descending, so the highest sales first and then the lowest sales. So now as you can see, we have now a rank customers, and we have a window function now together with the group by. So now let's go and execute this and see whether SQL can allow it. So let's run it, and as you can see, SQL runs it and we will get the rank for each customers. So the customer 3 has the highest total sale, then the customer number 1, and the last one gonna be customer number 2 with the lowest total sales. Alright, so we solved the tasks. We have now ranked the customers based on their total sales. So as you can see, SQL allows you to use window function together with the group by, but only with one rule. Anything that you are using inside the window function should be part of the group by. So for example, we fulfill the rule because we are using the sum of sales, and the sum of sales is a part of the group by, right? So now if I go, I just break the rule by not using the sum, just using the sales. So if I just remove the sum and use only the sales, SQL will not allow it because the sales is not part of the group by. So as you can see, SQL is very strict with this. If you want to use everything in one query without using like subqueries and so on, you have to use the exact same columns. So for example, if I go over here, instead of sales, I use the customer ID. So since the customer ID is a part of the group by, SQL can allow it. So be careful using window function together with the group by. As long as you are using the same columns, nothing gonna go wrong and SQL gonna allow it. Okay, so now I'm just gonna go and fix this and let's run it. So now as you can see, it's really easy if you follow those steps. First, build the query using group by. So don't you think about the window function, just build the group by. And then the next step, the last one, you go and define and build the window function. So with that, you can solve really nice analytical use cases with a simple one query without having you to build like subqueries and so on. You can go and use group by together with the window functions. Alright guys, so those are the 4 rules for the SQL window functions. Alright friends, so now let's have a quick recap about the SQL window functions. Let's start with the definition. It's gonna go and perform calculations like aggregations on top of subset of data without losing the level of details. So that means we can do aggregations and at the same time we are not losing the details. Now of course there is a lot of similarity between the window function and the group by, but the main difference is that window functions are very powerful and dynamic compared to the group by. We have way more functions than the group by, right? But now if you are doing data analysis and you have an advanced use case, then you have to go and use window function. It's more suitable for complex and advanced data analysis. But in the other hand, if you have a simple question, simple data analysis, then you can go and use the aggregate functions using the group by. And of course you can go and use them in the same query, in the same select. You can go and mix the group by together with the window function with only one rule. You have to use the same columns. And of course the first step is to do the group by, and then later you do the window function in the same query. And now to the next point about the window components. We have 2 main components. The first one is the window function and the second part is the window definition using the over clause. And inside the over clause we can define 3 things. If you want to divide the data to create windows, you can use the partition by. The second section we have the order by in order to sort your data. And the last part you can go and specify a subset of data like a frame within each window. Now let's move to the last part. We have rules for the SQL window functions. So the first thing is that if you have 2 window functions or multiple window functions, you cannot go and nest them together. You have to go and use multiple subqueries. The next point is that you can use the window function only in the select and the order by clause. So for example, you cannot use the window together with the where clause in order to filter the data. Talking about filtering data, how SQL gonna go and execute the window function? It's always after SQL filter the data. Alright, so those are the basic stuff about the SQL window function. Alright, so with that we have covered the basics about the SQL window functions. What is window functions? Why do we need it? The syntax, the main components. And now moving on to the next one, we're gonna learn how to aggregate your data using the window aggregate functions. Here we have 5 functions, so we can understand the syntax, how it works, the use cases, and everything. Okay guys, let's say that in our data we have the following informations. We have the months and the sales. Now if you apply any aggregate functions in SQL, what can happen? SQL gonna go through all rows of the window or the entire data and start aggregating the data. So that means in the result, in the output, SQL gonna give you one single aggregated value. SQL gonna go and summarize all those values, and in the output you're gonna find, for example here, the total sales is gonna be 175, or you can use the average or count the data and so on. So the aggregate functions gonna deliver at the end one aggregated value for a window or for the entire data. Okay, so now let's have a quick overview of the syntax of all aggregate functions. Most of them follow the same rule. So first, as usual, we have to define the function name, and in this example we have the average. Then to the next part, we have to define inside it as well the expression. We cannot leave it empty. So here we are using the sales, and the second rule for all functions beside the count, the data type of this field should be a number. And this of course makes sense, right? So we cannot find the average of the first name of customers or something like that. So we have to define a number. Then next we have to define the frame. So we have the partition by, and it is optional. So you could use it or leave it, depends. And then the next one we have the order by. It is as well optional. It is not a must or required. So you could use it or leave it. That means the whole definition of the window could be empty for the aggregate functions. Let's have a look to all functions. So we have the count, sum, average, min, max. And as you can see, only the count accepts all data types as an expression or arguments. All others require you to have a number as a data type. And for all functions, the partition by is optional, the same for order by and frame. So everything is optional over here. So now what we're going to do is that we're going to go and deep dive into each of those functions in order to understand how they work, what are the use cases, and of course we're going to practice in SQL. So we're going to start with the first one, with the function count. Hey friends, if you are new here, welcome. My name is Bara and I lead data projects in big companies like Mercedes-Benz, and I'm here to share my knowledge and best practices about data in high quality videos in this YouTube channel. So if you don't want to miss anything, make sure to subscribe. Now let's go back to the video. Okay, so what is the count function? It's really simple. It's gonna return the number of rows within each window. So it's gonna help you to understand how many rows do you have within each subset of data. So now let's go and understand how SQL works with this function. Alright guys, so now we have again this very simple example for the orders, and we have the following informations. We have the products and sales. And now we want to solve a very simple task. How many orders do we have within each product? So in order to solve it, we can use the function count like the following. So we can say count, and then we pass for it an argument or expression, the star. So with that, we are telling SQL, go and count how many rows do we have in our table. But we have a window definition like this over partition by products. So now what SQL gonna do? We're gonna go and divide the data sets into two partitions. We're gonna have one partition for the caps and another one for the gloves. So with that, SQL prepared our data into windows, and we are ready to do aggregations. So how many rows do we have within each window? It's gonna be 3. So for this window, it's gonna be 3 rows. And as well for the next window, we have as well 3 rows. So we can have 3, 3, and 3. It's very simple, right guys? We are just finding the number of rows within each window. But now with the aggregate functions, we have to be very careful with the null values. For the count star, as you can see over here, we are not specifying anything about the sales. So we are just saying, find me the number of rows. So that means SQL will just count the nulls as 1 row. So that means if we are using the star as an argument for the function count, the null will not affect anything. So whether we have nulls or not, we are just counting how many rows do we have inside our data. But in some scenarios, we should be ignoring the nulls in our count. For example, let's say that I would like to count how many sales do we have within each product. That means if we have nulls, it should not be counted. So now in order to achieve this task, what we're gonna do, we're gonna use, instead of a star over here, we're gonna have the field sales. So now with this, we are telling SQL, don't just count blindly how many rows do we have within each window. You should be very careful with the values. Find how many sales do we have within each window. So now let's see what can happen. For the first window, we have 3 sales, so we have 3 values. So the number of rows is correct. But for the next one, how many sales do we have? We have 2. So we have this sale and then the 70, but the last one is null, so it will not be counted. It will be ignored. That's why we're going to get in the output the value 2. We have 2 sales. So as you can see, the result did change, and we are now more sensitive to the null values. So be careful what you are specifying for the count. If you are using a column name like this, it will ignore the nulls. But if you have a star, it's just going to go and find how many rows do we have within each partition. Okay, so now if you go and compare the results side by side, you can see that if you specify a column within the count function, it's going to be sensitive with the nulls. So it's going to ignore it and will not use it within the aggregations. That's why we have here only 2 rows. But if you go and use the star within the count function, what's going to happen? SQL just going to go and count it. So we're going to find the number of rows that we have inside our table. And there is one more way in order to do the same thing here on the left side. You can use, instead of star, you can use a 1. So you might find it somewhere that people are using count 1 and then the same window function, and we will get exactly the same results. So the nulls will be counted and will not be ignored. So now you might ask me, which one should I use, the 1 or the star? Well, I would say it doesn't matter, right? We are getting the same results, and if you are thinking about the performance, I hardly find any differences between them. So you can go and try both of them and stick with the one that is giving you like more better performance. Now we have special case for the count function compared to all other aggregate functions. It allows any data type. So that means we can use numbers, we can use characters, dates, and so on. So that means we can go and specify something like the product for the count instead of sales. So we can go over here and say products, and it's gonna go and count how many rows do we have for the products. So it's going to be 3 over here, and since here we don't have any nulls, it's going to go and count it like this. So we have 3 rows. And be careful here, we are not counting the unique rows, we are just counting the rows that we have inside our data. So this will not be counted as 1, and this as well will not be 1. So we have 3 times the caps, that's why we have here 3. Okay, so now we have this very simple example. Find the total number of orders. This is very simple task in order to find how many rows, how many records do we have inside the table orders. So let's go and solve it. So let's start by selecting just star from the table orders without anything like this. So as you can see, we have 10 orders. It's very simple, it's very easy as well. But now let's say that you have thousands or millions of rows. You cannot do it like this by just checking the rows. What you're gonna do, you're gonna go and use the function count. So we can go over here and say counts star, and then let's give it a name, total orders. So let's go and execute it. So now as you can see, we got only 1 record, 1 value. We don't see any other details. We got the 10 orders. So this is the total number of orders. This is very helpful in order to understand the content of your data. So this we call it overall analysis, or let's say having the big numbers about your business. For example, how many orders do we have, how many customers, products, employees, and so on. So having those big numbers can help us to track our business, to understand how well we are doing with the orders and with the customers and so on. So this is the basics of reporting. Now let's go and extend our task by saying provide details such as the order ID and the order dates. So let's go and do that. So select order ID, order dates, and now of course we cannot do it like this, so let me just execute it. We will get an error because here we have different level of details in our select. So in order to solve this, what we're gonna do, we're gonna use the over clause, and with that we are telling SQL this is a window function. So now let's go and execute it. So with that you can see with that we have solved the task. We have details, we have the order ID, order dates. So this is the highest level of details since we have the order ID, and as well we have the highest level of aggregations. We have the total number of orders in the entire table orders. So now let's keep going and add more stuff to our task. Let's say that we want to find the total number of orders, but for each customers. So that means this time we have to go and divide our data by the customers. So let's go and do that. We're going to use as well a window function. So count star over, we have to divide the data using partition by, and we're going to use the field customer ID. So let's call it orders by customers, and I would like to see as well the customer informations in the query. That's why I'm gonna go and add it. All right, so that's all. Let's go and execute it. Now, as we learned before that, SQL first gonna go and divide the data. So that means we have 4 customers. We're gonna get 4 windows. The first window gonna be for the customer ID number 1, and as you can see we have 3 rows. That's why we have here 3 orders, and the same thing for the customer 2. We have 3 orders. Customer 3, 3 orders, but only the last customer, the customer ID number 4, we have only 1 row and 1 order. So now if you go and look to the total orders and the orders by customers, you can see now we are not doing the overall analysis, we are doing like comparison between different categories. And of course, in this example, the category is the customers. And with that, we can understand as well the behavior of our customers. So you can see that we have 3 customers that has exactly the same amount of orders. So they are very similar. but we have one extreme, which is the customer ID number 4. This customer has only one order, so this is the only customer that has different behavior than all other customers. So you see, with very simple query, we are able now to analyze our business and understand the behavior of our customers. So if you divide the data by partition by and using count, you can go and now compare stuff together. All right, so now let's keep moving. Next, we're going to understand the special cases that we have with the function count. So now we have this very simple task. It says find the total number of customers, and additionally we have to provide all customers details. So I think it's very easy to solve. What we're gonna do, we're gonna go and select star, since we need all details from customers, from sales customers. So let's just have a look. So we have 5 customers and the function is count star over, and we don't have to divide the data since we have to find the total number of customers for the entire table, and it's going to be total customers. So nothing new, that's it. We have 5 customers. And now, as we learned before, if you are passing the star to the count function, what you are telling to SQL is that just go and count how many rows do we have inside the table customers. So SQL just going to go and start counting, and it's going to say we have 5 customers, 5 rows. So it doesn't matter whether we have nulls inside our data, like in the last name or the score, it's just going to count the number of rows. So now let's say that we have the following task. It's going to say find the total number of scores for customers. So what do we need with this task is to find out how many scores inside our data. So as you can see, we have around 4 scores, but the last customer doesn't have any score. So we have it as a null. So the result should be 4. We cannot go now and use the star for it, because we're going to get 5. We have to go and count the scores. So let's see how we're going to do that. We're going to count as well, but this time the score, and the definition of the window going to be empty. So total scores, and let's go and execute this. So now we can see in the results we got 4 scores, which is very correct because SQL did ignore the null, and SQL now focusing only on one column. So focusing on those values, the nulls will not be counted. This is really great in order to check the quality of your data. So let's say that you are not expecting any nulls inside your data. So instead of going manually through the whole records, what you can do, you can go and find the total number of customers like this, and then you can go and count the total number of scores, and you can see there is a difference. So by just checking the data, I can say, you know what, we have one null without checking every record in our data. So with that, we can check the quality of our data and understand very quickly how many nulls do we have in the field score. And you can do the same stuff, for example, for the first name. Show it to you. So I'm just going to go and copy this, and let's say first name, or let's say country, actually. So I will go with the country. So let's go with the country, total countries. So let's go and execute this. So now if you check the result, you can see we have 5 rows with the country. So SQL gonna go and focus on the countries, and it will not find any nulls. So we have here complete data. We don't have any nulls because the total number of customers is equal to the total number of values within the country. And I can immediately find, okay, the data quality of the country is very good. All right, so now one more thing about the count function that we have learned before. We can use either star or 1 in order to count how many rows do we have. So let's just try it. I'm just gonna go and duplicate it, and instead of having a star, let's have 1. Just gonna give it a name. Here it's gonna be 1, and you are star. So let's go and execute it. So now if you check the output, we got exactly identical results. So there is no difference between those 2 queries. It's up to you. You can try it and check the performance. I usually go with the star instead of 1. Okay, so now we're going to talk about a very important use case for the SQL window function count that I frequently use in my real projects. The data that we use for data analysis has usually bad data quality. And if we don't find those data quality issues and we don't clean it before doing the analysis, what's gonna happen? We're gonna deliver bad results, bad analysis, which can lead to bad decisions. And one very common data quality issue that you might encounter in your project or on your data is that having duplicates. Duplicates are really bad for doing data analysis. So now in order to discover, or let's say identify the duplicates in our data, we can go and use the SQL window function count. So now let's go and have some examples. Okay, so now the task says, check whether the table orders contains any duplicate rows. So how are we gonna do that? By checking now the table orders over here, we can see that there are many orders, but how to find out the duplicates? Well, the first step is to understand what is the primary key of the table orders. So what we usually do, we go and check the data model if there is one. So for example, for this course, we have the following data model, and we can see that it is defined that the order ID is the primary key for the orders. The product ID is primary key for the products. So that means for our table, the orders, we have the order ID as the primary key, and it should be unique. It should not contain any duplicates. So now let's go to our data and check the order ID. By just looking at the data, you can see that we don't have any duplicates, right? All of them are unique. So we have 1, 2, 3, 4, and so on. But of course, in real projects, you cannot do it like this. You have to go and build a query in order to find out whether the primary key is unique. But now you might say the primary keys are usually unique because we can define it in the DDL, in the rules of building the table. Well, that's true. If you have it like this, then you don't have to find any duplicates. But usually in data analysis, we export a lot of files and a lot of data inside an extra database, and we don't build such a rules. So now in order to check the quality of the primary keys that you get from the source, we can use the count function. So let's go and build it. I'm just gonna select the order ID first as a detail, and now we're gonna do the following. So count and then star, and let's go and define the window. So it's gonna be partition by, and here the field gonna be the primary key. So the order ID. I'm checking now the quality of this field. This should not contain any duplicates. And now we're gonna go and give it a name, check primary key. So now my expectation is that the result of this should be at maximum 1. That means we have 1 row for each primary key, and that means as well it is unique. So if we get anything more than 1, then it means we have duplicates. Let's go and run the query, and as you can see in the results, we get for each primary key 1. So that's great. That means we don't have any duplicates inside our data, and the primary key is unique. So that means the table orders is clean and we don't have any duplicates inside it. Now let's check our database. We have here another table called orders archive. Let's go and check the table. So first, I'm just gonna go and select the data. So select from orders archive. So sales.orders archive. Let's check the results, and here we can see that we have exactly the same structure as the table orders. So now let's go and check whether the data quality is real clean. So now what we're gonna do, we're gonna use exactly the same query as before, but instead of using the table orders, we're gonna take the orders archive. So that's it. Let's go and execute it. So now by checking the data, you can see that we don't have everywhere 1. Sometimes we have 2 rows for the same primary key, which is really bad. So we have here for the order ID 4, we have 2 orders with the same order ID. And as well, for this order ID 6, we have 3 orders. That means those stuff are duplicates and they are against our data model. So now what else we can do is that to generate a list specifically for the data quality issue where we have duplicates. So anything that has 1, we are not interested in it. In order to do that, we're going to use the subquery. So let's say select star from, and then we can use the first query as a subquery. And we're going to say in our filter where the check primary key is higher than 1. So that means I need only the order IDs where we have duplicates. So let's go and execute this. Now I have a list with the primary keys where we have duplicates. So we have the order ID 4 and as well the order ID 6. So guys, as you can see, the window count function is wonderful in order to find data quality issues like the duplicates. Alright guys, so those are the 4 most important use cases in the SQL window function count. So the first one, we can use it in order to do overall analysis, or we can use it in order to do category analysis, like we have done the analysis on the customer behavior. Or another use case, we can use it in order to check the nulls inside our data. And the last use case, we can use it in order to identify or discover the data quality issue duplicates in our data. So now let's go and check the next function. We have the sum. Alright, so now let's understand what is the sum function. It's very simple. It's gonna return the sum of all values within each window. So now let's go and understand how SQL works with this function. Alright, so this is very easy and we are using the same simple example. And now we would like to find the total sales for each product. So we can define it like this: sum of sales, since we are finding the total sales. And then we define the window like this, over partition by products. So as we learned, SQL gonna go first and divide our data into 2 windows. So one window for the caps and another window for the gloves, right? So now after SQL define the windows, it's gonna go and start aggregating the data. So the sum of sales. That means for the first window, we have the 3 sales and it's gonna go and just simply summarize all those values. So we are adding 20 plus 10 plus 5 and we will get the result 35. So in the outputs, we will get everywhere 35. So that's it for the first window, and as you can see, SQL gonna go aggregate the data within each window separately. So that means as we are aggregating the data for the caps, SQL will not check anything with the gloves, so they are completely separated. So now it's gonna go for the next window, and here we have two values and a null. So again here the null will just be ignored. So what we're gonna have 30 plus 70, and the total sales for that's gonna be 100. So as you can see, it is very simple, right? So 100, 100, and so guys, that's it. It's really simple. We don't have here like a lot of special cases like the count function. It's only that it ignores the null in the calculation, and as well the requirement here, it allows only integers, or let's say numbers. So we cannot go and say sum the products, since the products are not numbers, they are characters. So you can only use numbers for the sum function. Let's go now and have some tasks and some use cases in order to practice in SQL. Find the total sales across all orders, and as well find the total sales for each product. And additionally, we have to provide some details like the order ID and the order date. So let's go and do that. Select order ID, order date, and let's get as well the sales. And now we have to find the total sales across all orders. That means we're going to use the window function sum sales, and the definition of the window going to be empty since we don't have to divide the data. So that's it, total sales, and we have to select the table sales orders. So that's it. Let's go and execute it. So with that, as you can see, we got all the details that we need, and as well the total sales, the summarization of all those sales in one field. So with that, we have our overall analysis, one big number for our reporting. We know how much sales we did made in the entire business. So now let's go for the next task. It says total sales for each product. I think you know already what we're gonna do. So sum of sales, and we're gonna do it like this, partition by product ID. So that's it. So we're gonna call it sales by products. And with that, we are dividing the data by the product. So let's go and execute it. So as you can see, we don't have the product information. So let's go and add the product ID in the query just in order to analyze the results. So we can see from the data that the winner is the product ID 101. So as you can see, we have here the highest sales if you compare it with the other products, and the lowest one gonna be the product ID 105. So as you can see, we can use the window function sum together with the partition by in order to compare stuff, to do comparison between the products in order to understand the performance, for example, of the products. So it's really great analysis for the performance. All right, now we're going to move to a very interesting use case for the aggregate functions, not only for the sum, but as well for the others. It is the comparison analysis. Okay, so let's understand quickly what is the comparison use cases. So it's going to go and compare the current value. For example, let's say we are currently at the month of March, and the sales is 30. So we're going to compare this value, the current sales, with an aggregated value. For example, let's say the total sales using the sum function. So what happens if you compare the current value with the total sales? You are comparing here or doing analysis called part to whole analysis, where it's going to help us to understand how important was the sales in this month compared to the total sales. Or we can go and compare it to the best months, to the highest value. For example, the highest value is June, and we can go and compare this month with the best months of the year, or to the lowest month in the year. Or we can go and compare the sales of the current month with the average in order to understand, are we above the typical sales or below the average? And this is very important analysis in order to study and understand the performance of the current data. All right, let's have an example in order to understand the use case. Find the percentage contribution of each product sales to the total sales. So let's go and solve it step by step. What we're gonna do, we're gonna go and let's select the order ID, and as well, let's take the product ID and the sales, just like this, from sales orders. So let's go and execute it. Okay, so now as you can see in the results, we got the first part of the equation. We have the sales, so nothing like crazy over here. Now we need the total sales over all data. So what we're gonna do, we're gonna have the sum of sales, and the definition gonna be empty. So this is the total sales. Let's go and execute it. So now we have everything for the equation. We have the sales and as well the total sales, and that is enough in order to find the percentage of the contribution. So the calculation for that is going to be very simple. We're going to divide the sales by the total sales. So it's really simple. Let's go and do that. It's going to be the sales divided by the total sales. So we're going to go and copy the whole window function over here, and then we're going to multiply it with 100. So that's it. Let's go and execute it. So now you notice that in the output we got zeros. This is because of the data type. So now if we go to our table over here on the left side, you can see that the orders has the data type of integer. So if you divide integers, you will not get a float or decimal number. You have to go and change the data type. So now what we're going to do, we're going to go and change the data type for one of them. So it's enough for the sales over here. So we're going to use the following statement. So cast sales as float. So that's it. I'm just converting the integer to floats. So that's it. Let me just give it a name. So it's going to be percentage of total. So that's it. Let's go and execute it. So now in the output, you can see we got now the percentage of the total, or let's say percentage of contribution. So now what we're going to do with that, we're going to go around those numbers because we have a lot of decimals. In order to do that, we're going to use the round function like this. Then we're going to have 2 decimals, and let's go and execute it. So now as you can see, it is really easier to read because we have only 2 decimals, and we can find immediately that the order 8 is the highest contributor to the total. So this is what we call part-to-whole analysis, where we find the percentage of total. It is very common analysis in order to understand the performance of each order compared to the total. So this is an example how the window function is helping us here to compare the current value with an aggregated value. All right, everyone, so that's all for the window function sum. Next, we're going to talk about the average function. Alright, so now let's understand what is an average function. As the name says, it's going to find the average of values within each window. So now let's go and understand how SQL works with the average. Alright, so now back to our very simple example, and the task says find the average sales for each product. So it's really easy. We're going to use the average, then pass to it the column sales, and we define the window like this, partition by products. So the first thing that SQL going to go is to define the window. So it's going to divide our data into 2 partitions, one for the caps and one for the gloves. And now I hope that everyone knows how to calculate the average. So as you know, that is going to go and summarize all the values and divide it by the number of rows. So it's going to go and summarize 20 plus 10 plus 5 and divide it on 3 rows, and the output going to be 11. So we're going to get it for each row. So as you can see, SQL just ignored everything in the next window. We are focusing only on the caps. Now SQL going to go to the second window and start doing the same aggregations, but here we have the special case of null. So the null is going to be ignored in the calculations, and we're going to have it like this. It's going to say, you know what, 30 plus 70, and we are just including 2 rows. So it's going to be divided by 2, and the average is going to be 50. So we will get the result 50 for each row, and we are completely ignoring the nulls. But now we might be in a scenario where your users understand the business like this. If we find a null in the sales, it means a 0. So there is no sales, and it is actually a 0, but we store it in the database as a null. So that means the average that you have provided is not really correct. We have to divide by 3. So that means first we have to handle the nulls before doing the aggregations, before finding the average. Now we're going to have a whole chapter on how to handle nulls in SQL, what are the different functions, but for now we're going to go with the function qualisk. Okay, so now what we're going to do, we will not use the sales as it is. First, we're going to handle the nulls. So that means we're going to use the qualisk sales and replace it with zeros. So as you can see, we are not using immediately the sales. We are handling it first, and then we're going to find the average. So SQL going to go over here, and if it finds any null, it's going to go and replace it with 0. And that's going to have then an effect on our average over here. So it's going to be 30 plus 7 plus 70, but now plus 0. And now we have 3 rows. So instead of dividing by 2, it's going to go and divide it by 3. And the total result is going to be like this, 33. So that means we're going to have in the output 33 for each row. And with that, we are now fulfilling the expectation from the business. If we have a null, it's going to be handled as 0, and the result is going to be more accurate. You see, right? It is very tricky. If you are doing data analysis and aggregations, be very careful with the nulls. Understand them, understand what they mean for the business, handle them correctly in order to get correct results in your analysis. So now let's go back in order to practice SQL using some tasks and use cases. Okay, so let's start with the basics. We have the following task: find the average sales across all orders. and as well find the average sales for each product, and don't forget the details. So now let's go and solve it step by step. So select order ID, order date, and let's get the sales as well, and let's go and find the average sales. So it's going to be a window function, and we have the sales inside it, the usual stuff. The window going to be empty, so average sales, we're going to call it. The table going to be sales orders. So that's it. Let's go and execute it. Oh, we have to select everything, of course. So what SQL did in the output, it's going to go and summarize all those values and then divide it by 10. So with that, we have the average sales of 38. Very easy. So this is again what we call an overall analysis. Let's move to the next one. Find the average sales for each product. So again, we're going to go and build the window function like this. Average sales over, and we're going to divide it by product ID. And we're going to call it average sales by products. And we're going to go and add the product ID in the query. So that's it. Let's go and execute. And we missed something here. So it is the partition by. Gonna execute again. So with that, we have the following data. So now SQL gonna go and divide the data. So for example, for this product, we have those 4 orders. So what's gonna happen, SQL gonna go and summarize the 4 values and then divide it by 4. That's why we have here 35. The same thing for the next order. It's gonna divide it by 3. And the last one is just gonna divide it by 1. That's why we have 60. So as you can see, the aggregation gonna done separately for each window. And this is as well a very nice way in order to compare the averages between the different products. Okay, so now let's have an example in order to learn how to deal with the nulls. Let's say that we have the following task: find the average scores of customers and show as well additional informations like the customer ID and the last name. So let's go and solve this. We are now targeting the table customers. So let's just select it first, like this. And now let's go and include the customer ID and the last name. And let's have as well the score. But this time we're going to go and find the average score. So it's going to be the average score. And since we don't partition the data, we're going to leave the definition like this, and it's gonna be the average score. So that's it. Let's go and execute it. So now as you can see, we have the average score of 625. SQL gonna go and summarize the 4 values and divide it by 4. But here we have a null. So now we have to understand the business or ask about it, what the null means in the scores of the customers. Is it 0 or is it something empty? If it's 0, then the average that we have is wrong because it should be divided by 5 and not 4. So let's say it's 0, that means we have to go and handle the nulls. So what we're going to do now, we're going to go and use the function qualis. So qualis, and for the score, and replace the null with 0. So you are the customer score. Let's go and execute this. So now as you can see, if there is a value, it's going to be exactly the same value, but only if you have a null, it's going to be replaced with 0. So now let's go and correct the average. I'm just going to do it like this. So let's go and copy the whole thing, but now instead of using the score, we're going to use the score that is handled with nulls. So I'm just going to go and replace it like this. So here, without nulls. So let's go and execute it. So now as you can see, we are getting more valid result at the output compared to the previous one. And this is only for the case if the null means 0. So guys, as you see, be very careful with the nulls, especially if you are doing aggregations, and handle it correctly before doing any aggregations like the average. Alright, moving on to the last use case, we have the comparison analysis, and the task says, find all orders where the sales are higher than the average sales across all orders. So that means we have to go and compare the current sales with the aggregated value, and this time the average of sales. So now let's go and do it step by step. So what we're gonna do, we're gonna go and select, of course, the order ID. What do we need? Let's take the product ID, and we need the current sales. So it's gonna be the sales as it is, and that's it for now. So from sales orders. So that's it. Let's go and execute it. So now by checking the result, you can see that we got the first part of the equation, right? We have the sales for each order. Now we need the second part, the average sales across all orders. In order to do that, we're going to go and use the window function average sales, and we're going to use over, since across all orders, that means it's going to be empty. So let's give it a name, average sales. So let's go and execute it. So now in the output, we got the average sales. So it's going to be 38. So now we need all the orders that are higher than the average. So as you can see, for example, the order 1 is not higher, but the order 4 is higher than the average. So in order to filter the data, we cannot use the window function in the where clause, right? So what we're gonna do, sadly, we're gonna go and use the subquery. So it's gonna be like this: select star from, and then we're gonna define the condition outside the subquery. So it's gonna be where the sales is higher than the average sales. So that's it. Let's go and execute it. And now, as you can see, it's very simple. We got all the orders that are higher than the average, right? So you can see all those sales are higher than the average. It would be nice if we can do all those stuff in the first query, but since we cannot do that, we need to use the subqueries in order to filter the data afterward. So with that, we can understand the importance of the comparison analysis. For example, here we are finding or evaluating the data whether they are above the average or below the average, and this is very important in the business analysis. Alright everyone, so that's all for the window function average. Next we're going to talk about two very interesting functions, the min and max. Alright guys, so what is min and max functions? They are very simple but yet very powerful functions for analytics. So the min simply is the function that's going to return the minimum, or let's say the lowest value within a window, where the max, it's exactly the opposite. It's going to find the maximum value or the highest value within a window. So now let's go and understand how SQL works with these functions. Alright, so now we have the same data and we have two tasks. First, we have to find the lowest sales for each product, and the second one, side by side, we would like to find the highest sales for each product. So we're going to go and use the min max, and as you can see, the syntax is very simple. Min the sales, and then the partition going to be by the products, and here as well the same stuff but having the max. Okay, so now let's see how SQL going to execute the first query. As usual, first it's going to prepare the data. So it's going to split the data into two windows, one for the caps and another one for the gloves, and after that it's going to search for the lowest sales within each window separately. So for the first window we have the following values: 20, 10 and 5, and of course the lowest value going to be the 5, so that's why SQL going to find it over here, and everywhere for this window it's going to be the value 5. So we have it as the lowest sales for the product caps. So now it's going to jump to the next window for the gloves and start searching the values. So as you can see, we have 30, 70 and null. Null will be ignored, so null will not be considered as the lowest value. So SQL going to find the lowest sales with the 30. So it's going to be actually the first row within this window, and the value, the output, going to be 30 for each row. So that's it. It's very simple, right? Now let's move to the next one. We have the same stuff but using max, so the data is partitions, and for the first partition, what is the highest value? It's gonna be the first row, right? The 20. So SQL gonna find it, and in the output we will get the highest sales, 20 for this window, and then it's gonna go to the second window and search for the highest value. So here we have two values, 30 and 70, and it's gonna be the 70, right? So it's gonna point it over here, and in the output we will get everywhere 70. So guys, it's really simple, right? Now let's back to our scenario in the average, where in our business we understand nulls as 0 in the sales. So that means first we have to handle the nulls and replace it with 0, and then we're gonna go and search for the value. So what's gonna happen? We're gonna go and replace nulls with 0. For the max, nothing gonna change. The highest value gonna be 70, and we're gonna get the same output. But for the min, now we have new lowest value. So it's not anymore the 30, it's actually the 0. So SQL gonna go over here and replace the 30 with nulls. So nulls is the lowest sales for the product gloves. So again guys, the nulls are very tricky, and those functions are really sensitive with the nulls. Understand what the nulls means and handle it correctly so that you get correct results in the output. So that's it. Let's go back to SQL to have some tasks and use cases in order to practice SQL. Alright everyone, let's start with the basic stuff. Find the highest and lowest sales of all orders, and as well find the highest and lowest sales for each product, and we have to provide additional informations. So let's go and solve it. Select order ID, order date, and let's take as well the product ID. Now let's find the highest sales of all orders. It's gonna be the max function for the sales, and the window function gonna be empty since of all orders. So you are the highest sales. Let's go for the lowest sales of all orders. It's gonna be exactly the opposite, the min function for sales over, then we have the lowest sales. So I'm just gonna make it bigger, capital. So let's select the table, sales orders. So I think that's it. Let's have as well the sales actually. All right, so now let's go and execute it. So now this is very simple, right? This is the whole sales. What is the highest sales? We have the 90 of the order 8. So as you can see, we have now the highest sales, the 90, and the lowest sales is the 10. The first order is the lowest. So it's very easy. Now we're going to go and repeat the same stuff for the product. So we have go and partition the data by the product ID. So what I'm going to do, I'm just going to go and copy paste stuff around. So the first one going to be partition by the product ID. So highest sales by product. And the next one going to be the same stuff. Copy paste by the product. So that's it. Let's go and execute it. So now again, the data going to be partitioned and divided by the product. So for the first window, what is the highest sales? It's going to be the 90 and the lowest sales is going to be the 10. So it's exactly like the overall, right? Now let's go to the second window over here. We can see that the lowest or the highest sales is the 60, the first one, and the lowest this time is 15. And this is great in order to see that the SQL can execute each of those functions for each window separately. So let's go to the last window. It's a funny one. So the sales is 60 and we have only one row. So it's going to be the highest and as well the lowest sales. So with that, as you can see, we can define a range for each product, and the ranges are different from each product to another one. For example, for this product 101, the range from 10 until 90, but for the second product, we have it between 15 and 60. Okay guys, let's move to the next one, which is one of my favorites in the window function, where we filter the data using the min-max functions. Let's have the following task. It says, show the employees who have the highest salaries. So this sounds very simple, but we can use the help of window functions in order to solve it. So now we are working with the table employees. Let's just select the data. So select from sales employees. So that's it. Let's go and execute it. So now we have 5 employees and we have those different salaries. Let's go and find the highest salary. So max salary, and let's use the window function over, but we don't partition the data at all. So it's going to be like this, highest salary. So let's go and execute it. And now by checking the results, we got a new column called highest salary, and inside it we have the 90K. So if you check those 5 salaries, you can see that the highest is from the employee Michael. But still the task is not solved. We have to show only the employees who have the highest salaries. So we have somehow to filter the data and only show this employee. So in order to do that, we have to use the subqueries, since we cannot use the window function in the where clause. So what we're going to do, select star from, and then our first query going to be the inner query. So we have the following condition. It's going to be the salary should be equal to the highest salary. So it's very simple. So with that, we are comparing the salaries with the highest salaries. If there is a match, the data going to be presented. So let's go and execute that. And that's it. As you can see, we got the employee with the highest salary. But if there are like multiple employees with the same salary of 90K, of course, we're going to get it in the results. I think Michael going to need a new job, right?
This is the worst.
So this is another use case for the window functions min-max. Alright, so now we come to the use case of the comparison analysis, where we want to compare the current sales with the highest and the lowest value. So we have the following task. It says, find the deviation of each sales from the minimum and the maximum sales amount. So now as you can see, this is our sales, this is the highest and this is the lowest. So now we just have to go and subtract the data from each other's in order to get the deviation. So it's very simple. Let's get the first deviation, where we're gonna go and subtract the sales with the lowest value. So it's gonna be like this. So now what we are doing over here, we are subtracting the sales from the lowest sales of all records. So we're gonna go and call you deviation from min. So let's go and execute it. So now we can see from those values, how far is the current value from the extreme. The extreme here is the lowest value. So this is a really great way on to analyze the extremes in your data. So now as we are near to the extreme, the value gonna be low. So as you can see here, we have a 0. This is the lowest because we have it exactly as the extreme. So actually, this is our value, so the 10. Now, the next one is a little bit far away from the extreme, which is 15. So we have it here as a 5. So this is not far away from our extreme value. And then if you check this value over here, we have it 80. So the distance is very far away from our extreme value, the lowest sales. So this is really nice analysis in order to analyze and evaluate the sales of your data. Now, of course, we can go and evaluate our data with another extreme, which is the highest sales. So in order to do that, we're gonna first say, let's get the highest sales and subtract it from the sales. So you are the deviation from the max. So let's go and execute it. So now we can see in the output, we're gonna get exactly the opposite distances. So the order number 1 is the farthest from the extreme. So as you can see, we have the value of 80, and the order 8 is the identical one. So that's why we have the distance of 0. So now we can see as well very quickly which data points are the nearest to the extreme, to the highest sales. So as you can see, guys, using the window function min and max, it is very powerful in order to understand and evaluate your data points to the extremes. Alright everyone, so now we're going to focus on very important use case. One of the must-know use cases for data aggregations is doing running total and rolling total. These two concepts are very important for data analysis and doing reporting that you must know. The key use case for those two concepts is to do tracking. For example, we can go and track the current total sales with the target sales in our business, and as well it's great in order to do historical analysis for the trends. Okay, so now the question is, what is running and rolling total? They are basically very similar. They're gonna go and aggregate a sequence of members, and the aggregation gonna get updated each time we add a new member to the sequence. A sequence could be like a time sequence. That's why we call this type and analyzes over time. So now we still have the question, what is the difference between the running and the rolling totals? The running total gonna go and aggregate everything from the beginning until the current data point without dropping off any old data. Where on the other hand, in the rolling total, it's gonna go and focus on a specific time window, like the last 30 days or the last 2 months, and each time we add a new member or a new data point to the window, we will be dropping off the oldest data point in the window. And with this, we're gonna get the effect of rolling, or let's say shifting window. Okay, I totally understand if this might be complicated. Now let's go and have a very simple example in order to understand this concept and as well how we can solve it using SQL. Alright guys, so now we have a very simple example. We have the months and sales, and we have it twice because I want to show you side by side how SQL works with the running total and the rolling total. So now what is the task on the left side? We want to find the running total of sales for each month, and on the right side we would like to find 3-month rolling total of the sales for each month. So they sound very similar, but on the right side we have only fixed window. So now how we can solve this using SQL? On the left side we can use sum of sales, so we want to go and aggregate all the sales using the sum function, and the definition for the window gonna be like this: order by month. And of course you can go and do anything, like you can have here an average, and if you use an average with order by, you will get the running average or the running max or the running count and so on. So that means always if you go and mix an aggregate function together with an order by, you will generate an effect of running total. Now on the right side we're gonna have the same stuff, so we can have an aggregate function together with order by, so sum of sales, order by month. So far we have everything like the left side, right? But now you might ask, why is SQL gonna go and generate this effect, the running total? We didn't here specify like crazy stuff, right? It's all about the definition of the frame clause. So now do you remember, if you use an order by and you don't specify a frame clause, you will get like hidden or let's say default frame clause, and it's gonna look like this: rows between unbounded preceding and current row. And what was the definition of the running total? It's gonna go and aggregate all the data from the very first beginning, well, the unbounded preceding, until the current position, the current row, without dropping off any old members. So that means the definition of the running total gonna be the exact definition of the default frame clause. That's why SQL gonna go and generate the effect of the running total. Now let's go to the right side, the rolling total. Here again we have the same stuff, right? We're gonna go and aggregate the data using the sum function, and we're gonna go and store the data order by month. So with that, we are as well generating the effect of running total. So each time you use order by with aggregate function. So now in the running total, we want always to specify a frame. So here in this example, 3 months. So that means if we are getting a new month, we don't want to include the latest months. We want always to be fixed window. Now, in order to have this fixed window effect, we have to go and redefine the frame clause. Because if you leave it as a default like the running total, the frame gonna keep extending. You will see this effect in the example. So now we define it like this: rows between 2 preceding and current row. So the total number of rows gonna be included in each window gonna be maximum of 3 months. So now I know you might think, Para, what you are talking about? You didn't get anything. It's totally normal. You will understand it only with an example. So in order to do this, let's start with the left side. So first, SQL gonna go and sort the data. So everything is sorted from the smallest month until the highest one. So from January until July, everything is good. And now SQL gonna go and start working with the frame. So the frame says unbounded preceding. So this is gonna be static. It's gonna be always pointing to January. This is the unbounded preceding, the first row in the dataset. And now, of course, we are starting from top to bottom. The current row gonna be pointing as well to January. So the frame gonna look like this. It's gonna be only 1 row. And the total sale of this row gonna be 20. So that's why we're gonna have in the output 20. So now let's move to the right side. The current row gonna be as well January. And what is the 2 preceding? We don't have it yet, so it's gonna be pointing maybe somewhere here before the table. So again, what is the frame? It's gonna be as well 1 row. So in the output, we will get exactly the same result, 20. So far there is no differences between the running total and the rolling total. But let's keep going. Now we're gonna go to the next row over here. So what's gonna happen to our frame? It's gonna go and extend, right? So we're gonna have now 2 months in this frame. And what is the total sales over here? It's gonna be 30. So we added a new member. You can calculate it like this: either go and calculate all the sales within the frame, or you can go and say this is the previous aggregated value plus the new member. So the previous one was 20, the new member is 10, we will get 30. Both of them is correct. So now let's move to the right side. What's gonna happen? We're gonna be as well at February. The 2 preceding is still like pointing somewhere outside. And here the window gonna go and extend like this. We have 2 months. And the same aggregation can happen, so we have 30. So far, nothing crazy, right? Let's go to the next month, March. The frame gonna be extended, so we have now 3 months. And the aggregation gonna be either here, 60 or 30 plus 30. We will get the running total of 60. And now on the right side, what's gonna happen? We're gonna point as well to March. And this time, the 2 preceding gonna be pointing to January. And this is the first time we are getting the whole fixed frame, right? So we have here 3 months in this frame. So what is the total of that? It's gonna be 60. Okay, so now you say, okay, we're still getting the same results. So there's no difference. I'm gonna say, wait for it. It's gonna be the next one. So as we go to April, the effect here is that the frame gonna get extended to 4 months, because always we start from the first month until the current month without dropping any member outside. So what is the total of this? It's gonna be 65. Sorry, like this. So now on the right side, what's gonna happen? We're gonna go and add a new member, the April, but we are at the maximum size of the window. We have only 3, and that's because the 2 preceding gonna shift as well down over here. So the boundary gonna be from February until April, and with that we are dropping off January. And now you're gonna see the effect. It is sliding, it is rolling or shifting from top to bottom. And that's because the boundaries as well shifting. So you can see now the effect of the rolling total. The newest member gonna be added, the oldest member gonna be out. We are allowed only to have 3 months. So what is the total of this? It's gonna be 45. So this times we are not aggregating this value, the 60, together with the 5. We are aggregating the values within the window. So now let's keep going. Now we are at June. What can happen on the left side? The frame gonna get bigger. And with that, we will get the result of 135. So the frame is getting really bigger, but on the right side, it's gonna have a fixed frame. So we are just sliding, shifting, and rolling. So with that, we are adding a new member. Another member is leaving, the oldest one, and the total over here gonna be 105. And now we're gonna go to the last row. We will have everything for the running total. So the whole data set is gonna be aggregated. So this is the maximum what we're gonna get. It's gonna be around 175. But on the right side, it's just gonna keep shifting until we reach the last record. The window, the frame, gonna be as well shifting like this. So the total of this is gonna be 105. Okay guys, so you see, it's very simple. The running total is always consider everything from the starting position until the current row without dropping any member. The rolling total, it's always drop the oldest member in order to add something new, and the window is keep shifting. So the running total is very great in order to do tracking, like for example budget tracking, or we track for example the current total sales with a target or something like that. So always we are considering the whole data sets, but with the rolling total we always do here focused analysis. We are always interested with the window of 3 months. So they might sound very similar, but they have completely different scope for analysis, but both of them are doing aggregations over time. So they're gonna help us to do analysis over time, like checking whether our business is growing over time or declining. So guys, as you can see, using very simple SQLs, using the window functions, we can do really great analysis on our data. So those stuff are really fundamental of data analysis or doing reporting for our business. So window functions are really powerful for data analytics. Okay, so now we have the following task and it says calculate the moving average of sales for each product over the time. So now we have here something called moving average. It is very similar to the running total. In the running total we used count and sum and so on, but here we're gonna go and use the function average, and instead of calling it running average we call it moving average. So let's go and solve the task. Let's start always by selecting the usual stuff. So let's get the order ID, let's get the product ID, and I would say since it's over the time I will get the order date as well, and the last one the sales. From our table, sales, orders. So that's it. Let's go and execute it. So now we got our 10 orders with the products, order date, and sales. Let's start building our window function step by step. So which function do we need? We need the average. This is the easiest one. It says moving average, so that's it. We need the sales, so it's going to be the average of sales. Let's go and define the window. So now do we have to divide the data, partition the data? Well, yes, it says for each product. That means we're going to go and use the partition by clause by the product ID. So now I would say that's it for the first step. So average by product. So let's go and execute it. So now if you check the result, you can see that we got our windows. So the first one for the product 101, and the total average of the sales gonna be 35. So we have like aggregated one value for each window, the same thing for the next product and for the next and so on. So we don't have any progress over time or something like moving average over the time, right? We don't have this effect. We have just one average for each window. So now in order to have the effect of the moving average, it's going to be like the running total, we have to use the aggregate function together with the order by. So I'm just going to make it in the new column. I'm just going to copy everything like here. And now what we're going to do, order by. And since it's over the time, we're going to go and use the order dates. Order dates, and we're gonna have it as ascending because it's overtime. Overtime always like start with the earliest dates, end up with the latest dates. So from the lowest to the highest, we're gonna leave it like this. So let's call it moving average. So now let's go and execute it, and we got here an extra comma because of the copy paste. So let's execute it again. All right, so now let's check the results. Let's take the first window over here, and you can see we have on the moving average like a progress. So it starts with 10, 15, 14, 35. So there is like moving average. We don't have one solid number for the average. We have different values. So now how is SQL gonna solve this? It's really simple. It's gonna start row by row. So the first row, what is the average of 10? It's gonna be 10. Then moving on to the next one, it's gonna be 10 plus 20 divided by 2, you will get 15. So now moving to the third one, although 3 values gonna be summarized, divided by 3, you will get 40. And now to the last row in the window, it's gonna be summarizing all those 4 values divided by 4, and you will get 35. And this is exactly the same value in the previous column. You have here the average by products. We don't have order by. You got as well 35, exactly like this last row, and that's because we have the same calculation. It is summarizing all those 4 values, dividing it by 4. But now it's interesting, the next value. So as you can see, the next value, it comes from another window. So you see here we have 15 for the product 102. but the average is going to be as well 15. So SQL is not considering the old values from the other window. So SQL gonna calculate each window separately. So it's again here, this is the first value of this window, 15, the average 15, then the same stuff, right? So summarizing those values divided by 2 and so on. And this we call in data analysis, this last field over here, we call it a moving average, and you can implement it very simply using an average function together with the order by. Alright, let's move to the next task, and it says calculate the moving average of sales for each product over time, including only the next order. So as you can see, the first part we have already done it, right? We have the moving average and divided by partition by for the products, but here we have more specifications. It says including only the next order. That means we are talking about the current order and as well the next order. So here we have like a fixed frame or fixed window. So we don't need the whole average of the window. We need only maximum 2 orders in each calculation. So how are we gonna do that? We can have our custom frame clause inside our window function. So that means we cannot leave it as a default. We have to specify it. So let's go and do that. I will just copy the old definition of the window because we have the exact stuff. So we have the average sales over partition by product ID, order by date. So this is the first part. So now we would like to have this fixed window. So we're gonna go now and define our frame clause. I'm just gonna zoom out a little bit. It's gonna be rows between. So we have now the boundaries of the frame. It says including the next order. So we're gonna go and use the following. So the first boundary gonna be the current row, and since it's next order, so it's gonna be 1 following. So that is our frame, including only the next order, and we have it like this, 1 following. Let's call it, rolling average. So that's it. Let's go and execute. So now let's go and check the result. You can see the moving average has completely different values as the rolling average. So let's go and understand why. We're gonna do it row by row. Let's take the first row over here. So the sales here is 10. And the rolling average is 15. So why is that? Because in the calculation we are considering the next value. So 10 plus 20 divided by 2, you will get 15. So that means the SQL defined the frame like this, those 2 rows for this calculation for the first row. So now moving on to the second row, SQL gonna include as well the third one, right? The next one. But since the window is only 2 orders, it's gonna go and drop the first row. So the next frame gonna be like this, and as you can see, it's gonna be 20 plus 19 divided by 2, you will get 55. So now you can see the effect of the rolling average, right? So now for the next one, it's gonna be exact same. So we are at the third row, it's gonna go and include the next one, and we're gonna get the same value because 19 plus 20 divided by 2, you will get 55. Now, interesting to the last row in the window over here, it will not go and consider the next value because it is outside of the window. So it's gonna be 20 and it's gonna stay as well 20. So that's it. Alright guys, so with that we have learned about the moving average, the rolling average, and those amazing concepts using the window function. Alright, now we can have a quick overview of the different use cases in the aggregate functions and how the definition of the window gonna change the whole use case. So now the first use case is finding the overall total, and here if you don't define anything in the window, if you leave it empty, what can happen? You are doing here overall analysis. So you're gonna go and aggregate the whole data sets and then provide this aggregation for each row. So this is what happens if you leave it empty, you don't define anything, you are aggregating the whole data sets. Now moving to the next step, we can do analysis called total pair groups. So what we're gonna do, we will add partition by to the definition of the window. So by adding, for example, here partition by products, what can happen? The data going to be splitted into 2 categories or 2 groups, and the aggregation going to be done for each window separately. This is of course a great analysis in order to go and compare different products, like here the caps and gloves. So this is helpful in order to compare categories. So you can do this analysis total pair groups if you use the partition by. Now if you go and use the order by, you're going to land in the third use case. As we learned, we will be doing running total. So as you can see here in the output, we are building a cumulative value for the sales, and this is going to help us in order to do progress over time analysis in order to understand the performance of our business. And now moving on to the last use case, the final phase of the window function with the aggregation. Here you have the aggregate function together with the order by with customized fixed window. And of course, we can use it in order to help us building progress over time in specific fixed window. And of course, you can use those use cases. You will get the same effect if you use the other functions, not only the sum. You can use average, count, max, min, so all aggregate functions. So guys, as you can see, the window function in SQL is very important in order to do data analytics. By just like changing the part of the window, you are generating a whole new use case for data analytics. Alright friends, so now let's do a quick recap about the window aggregate functions. So what they do, they're gonna go and aggregate a set of values and return a single aggregated value for each row. So it's very similar to the group by, but here we don't lose details. Now to the next point, what are the rules for the syntax? About the expressions, they all expect a number in the expression. So you have to pass a number like sales or any integer, but only for the count, you can go and use any data type. And the things for the aggregate functions are very simple. Everything is optional inside the definition of the over clause or the definition of the window. So you can go and use partition by, order by, frames or not, or just leave everything empty. So everything is optional. So now as we learned, we have a lot of use cases for the aggregate functions and they are really amazing for analytics. So the first one, the simplest one, you can do overall analysis if you just leave the window function empty. So you will get one big number about your business. And the next use case, we can do total pair groups analysis. As you learned, we can use partition by in order to compare categories with each others, like comparing the products or customers and so on. Moving on to the next one, we can do part to whole analysis. We can go and compare the performance of each data point with the overall. So you can, for example, compare the sales to the total sales in the window or to the all data sets. And we have many comparison analyses. We can go and compare the current value with the average, or we can compare them to the extreme, to the highest sales, to the lowest sales, and so on. And another use case, we can go and identify data quality issues in our data. So we can go, for example, and identify duplicates using the count function. Moving on to the next use case, we have the outlier detection. We can go and find out which data points are above the average and below the average and so on. Then the next one, we have the running total. As we learned, it is a great tool in order to track the progress or to monitor the performance of our business over the time. Or if you want to be more specific, you can go and use the rolling total in order to have like a specific window and only track this window like 3 months or something like that. And the last use case, we can go and calculate the moving average of our data. So it's really amazing how order by and aggregate functions can open for you a door for amazing or advanced analyzers. So guys, as you can see, we have a lot of use cases for the window aggregate functions in the world of data analytics. Alright, so with that you have learned how to aggregate your data using 4 different SQL window functions and their use cases. Moving on to the next one, we're going to learn how to rank your data using 6 different SQL window functions. So as usual, we're going to do a deep dive into the syntax, how SQL works, and the different use cases. They are amazing for data analytics. Alright, so now let's say that we have the following data. We have products and their sales. If you want now to go and rank your products, first you have to sort the data based on something, like for example, ranking the products based on their sales. So that means SQL first gonna go and start sorting your data from the highest to the lowest. So sorting the data is always the first thing SQL has to do before ranking anything. Now, in order to rank our data, we have 2 methods. The first method, we call it the integer-based ranking. So that means SQL gonna go and assign for each row an integer, a whole number, based on the position of the row. So now by looking to the example, the first row we have the product E with the sales 70, it's gonna be ranked number 1. Then the next row, the product B with the 30 sales, we will get the rank number 2. Then the next one gonna be 3, 4, and the last one gonna be 5. So that means SQL here is assigning an integer for each row based on their position in the sorted list. So this method, we call it integer-based ranking. Now let's go to the second method. We have the percentage-based ranking. So in this method, SQL gonna go first and calculate the relative position of the row compared to all others, and then assign a percentage for each row. So here in the output, SQL gonna start assigning percentages instead of integer, and we're gonna have a scale from 0 to 1. So now if you go and compare both of the methods, you can see that on the left side, on the integer-based ranking, we have discrete, distinct values. So it starts from 1, then 2, 3, and end up in this example by 5. So it really depends on how many rows do we have in the results. So it could be 5, it could be 500, 5 million, and so on. But in the right side, we have always the same scale from 1 to 0. So between 0 and 1, we have infinite number of data points, and this scale we call it a normalized scale, or we call it continuous scale, continuous values. So now the question is when to use which method. So for example, for the percentage-based ranking, it is great to answer such questions. Find the top 20% products based on their sales. So this method is a great way in order to understand the contributions of data values to the overall total. And we call this kind of analysis a distribution analysis, where in the other hand, in the integer-based ranking, we can answer questions like find the top 3 products. So with this question, we are not interested about the contributions of each product to the overall total. We are just interested in the position of the value within a list. So this is as well very commonly used analysis in reporting. We call it top button and analyzers. So now let's group up our ranking functions based on those two methods. For the first group, in the integer-based ranking, we have 4 functions: row number, rank, dense rank, and NTILE. But in the other hand, we have only 2 functions that generate percentage-based ranking. We have the cumulist and as well the percentile. So now that was an introduction, an overview of those methods and how we group up those ranking functions. Next, we're gonna go and learn about the syntax of the ranking functions. Most of them follow the same rules. So for example, we start always with the function name. So we have here the rank, but as you can see, we don't use any expressions. So they don't allow you to use any argument inside it. It must be empty. So this is the first rule using rank functions. Then about the definition of the window, as usual, the partition by, it is an optional thing. You can use it or leave it. And now to the second part, we have the order by. It is as well required. So you must order the data or sort your data in order to do ranking. So you cannot leave it empty. So that means for the definition of the window, at least we should have an order by, for example, here sales. So we cannot leave it empty. All right. So the 2 requirements, you cannot use any expressions for those functions. And as well, you have to sort your data using order by. Okay, so now let's have an overview of all functions. So as you can see, all those functions are ranking functions, and almost all of them don't allow to use any expressions inside them. Beside this function here, we have the NTILE. It accepts a number inside it. So that means you cannot use it empty. You should use a number inside it. All others must be empty. So now for the partition by, all of them are optional, and for the order by, all of them are required. So you must use order by, and the frame clause, they are not allowed to use in the ranking functions. So you cannot change the definition of the frame inside the window function. So now what we're going to do as usual, we're going to go and deep dive into all of those functions in order to understand when to use them and what are the use cases, and as well practice in SQL. So we're going to start with the first one, the row number. Hi friends, I just checked the YouTube statistics and it says since the creation of this channel, over 70% of you still watching the videos and the content frequently without subscribing. So here's the deal. If you ever enjoyed watching my contents, please subscribe. It's gonna help the channel more than I can explain, and I promise in return I'm gonna keep pushing on making high quality videos about data. Do we have a deal? Alright, let's go back to the video. Alright, so what is a row number? In SQL, the row number function gonna go and assign for each row a unique number as a rank, and it doesn't care at all about the ties. That means if you have 2 rows sharing the same value, they will not share the same rank. Okay, so now we have a very simple example. We have a list of all sales, and we have the following query. So it's gonna start with the ranking function, a row number. It doesn't accept any argument inside it, and the definition of the window gonna be like this: order by sales disk. So that means we're gonna go and sort the data descending from the highest to the lowest. So SQL gonna go and do the following. The highest gonna be the 100, the lowest gonna be the 20, and here we have twice the 80. So now once SQL done sorting the data, what's gonna happen? It's gonna start assigning a rank. So the row number gonna go and assign a unique number for each row. So that means it's gonna start with the first one, the 100 gonna be the rank number 1. The next one gonna be rank number 2. The 80 gonna be rank number 3, and the 54, and then the last one gonna be 5. And now if you check the output, you can see that all those numbers are unique. We don't have any repetitions. So 1, 2, 3, 4, 5, there is no repetitions. They are unique, distinct value, and as well there are no skipping of ranking. So that means we have here 1, 2, 3. There is no jumping to 6, 7 or something. There are clear sequence of distinct value, and there are no gaps. But still there is something special in our data. We can see that in the sales, we have the same value twice. So we have 2 rows with the same sales. As you can see in the row number, they will get distinct value. So they will not share the same ranking. So that means row number does not handle the ties. If you have multiple rows sharing the same values, they will not share the same rank. They're gonna have a distinct rank, different ranks. So this is how the row number works in SQL. It generates unique ranks for each row. It does not handle the ties, and as well, it doesn't leave any gaps, so there is no skipping of ranking. So now let's go to SQL in order to have few examples and use cases. Alright, so now we have the following task. It's very simple. Rank the orders based on their sales from the highest to the lowest. So now this is very easy. We're gonna go and select first the data. So order ID, product ID. Let's take the sales as well and select the table. So it's gonna be sales orders. Let's go and execute it. So with that, we got all our orders. What we're gonna do now is to assign for each row a rank. So that means we need a column here that contains the rank for each row. So in order to do that, we're gonna go and use the window function row number. It doesn't accept any argument inside it, so it should be empty. And then we have to define the window. So as we learned in the ranking functions, we cannot leave it empty. We have to sort the data using order by. So order by is a must. We don't have to use any partition by, so we can rank all the data that we have inside the table. So how to sort the data? It says it should be based on their sales from highest to lowest. That means we order by sales. Since from highest to lowest, we have to use the descending. And now we're going to go and give it a name, sales rank, and let's say row, since we are using the row number. So that's it. It's very simple. Let's go and execute it. So now let's have a look to the results. Before, SQL did sort the data by the order ID since we didn't define anything. But since now we are order by sale descending, SQL went and sorted the data by the sales from the highest to the lowest and start assigning a rank, or let's say an integer, unique integer for each row. So now the highest order gonna be the order number 8. We have the sales of 90. This is the highest one. So as you can see, we have 1, 2, 3, 4, 5 until 10. So now by checking the result, you can see that the ranking here is unique. So there is no duplicates over here, and as well there is no skipping or gaps. So we have everything between 1 and 10. Even though that we have in our data a couple of sales that's sharing the same value. So for example, we have those 2 orders. You can see both of them has the 60 at the sales, but they don't share the same ranking, right? So we have here as well the 9 and 3. They share the same value 20, but they don't share the same ranking. So with that, we have solved the task. It's very simple. We have now a rank based on the sales from highest to the lowest. Alright, so what is a rank function? In SQL, the rank function gonna go and assign for each row a number, a rank, and this time it's gonna go and handle the ties. So that means if in your data you have 2 rows having the same values, they're gonna share the same ranking. One thing about the ranking function is that it's gonna go and leave gaps in the ranking. So there is possibility of skipping ranks. In order to understand how the rank function works in SQL, we're gonna have a very simple example. Alright, so again with the same data, but with different function. So our window looks like this. It starts with the function rank, doesn't accept any argument inside it. Then we have the window like this, order by, sales, descending from the highest to the lowest, and our data is already sorted like that. So now how is SQL gonna go and assign the ranks? The first row gonna be the highest rank, so the value 100 gonna be 1. Then the second one gonna be 2. But now for the third one, as you can see, we have here two values that are the same. So we have a tie, and this time SQL gonna go and as well let them to share the same rank. So both of them gonna be the rank 2. So it's not like the row number where we have over here 3. This time we have 2 because we have a tie. So having same values means they're gonna share the same rank. And now moving to the next value gonna be a tricky one, because if you check over here, you can see that the next rank should be like the 3, right? So we have 1, 2, and then the next value that generated in the rank should be 3. But SQL gonna say, you know what? This value position gonna be number 4. So as you can see, 1, 2, 3, 4. So actually, the position number here is 4, and SQL gonna go and give it the rank of 4. So with that, SQL gonna be leaving a gap in the ranking. You can see we are skipping the rank number 3. And this always happens once you have a tie where you are sharing the same ranking. So for the next one, it's gonna be easy. It's gonna be the row number 5. So now by looking to the output of the rank function, you can see that we don't have a unique ranking here. We have shared ranking in case of the ties. So it handles the ties, but here we have gaps in the ranks. So we are skipping ranks. When I think about the rank function, I think about the Olympics. If two athletes tie for the gold medal, the first place, there will be no silver medal for the second place. The next medal gonna be given to the bronze, to the third place. Alright, so now let's go in SQL in order to practice the rank function. Alright, now we're gonna go and solve the same task but using the rank function. So what we're gonna do, we're gonna stay with the same example over here, and we're gonna rank the order based on their sales from highest to lowest, but this time using the rank function. So we use the rank and everything inside is gonna be empty. And then our window gonna be exactly the same as before. So over, order by, sales, and disk. So let's give it a name, sales rank. Yeah, let's give it a rank. So that's it. As you can see, the syntax is very simple and very similar to the row number. We just changed the function. So now let's go and execute this in order to check the results. So now let's go and check the results by looking to the new rank. If you go and compare it with the old rank, we can see that we are sharing some ranking, right? We have here the 2 twice. So the rank number 2, we have it twice because we have over here the same value. So 60, 60, we have it here 2 and 2. But if you compare it to the row number, you can see that it is not sharing the same ranking. So this is one difference, and as well here the same thing. They have the same value. The sales is 20, so we have it twice. The rank number 7, and here we have it as different values. And the next value, as you can see, we are skipping the rank. So there is gap. There is no rank of 8. So you can see that this is the row number 9, and that's why it gets the 9. The same thing, I believe, over here. So now if you check those two ranks, the next one should be 3, but since it is in the row number 4, it's gonna get the rank 4. So by checking the results, we can see that sharing the same ranks, and as well we have gaps. So this is how the rank works. Alright, so what is a dense rank? It is very similar to the ranking function. It's gonna go and assign for each row a number, a rank, and it as well handles the ties. So same values, they're gonna share the same ranking, but this time it doesn't leave any gaps like the rank function. So the dense rank, it will not leave any gaps, it will not skip any ranking. So in order to understand this, we're gonna have a very simple example. So let's go. Alright, so again the same data but with different function. We have this time the rank function dense rank, and the window gonna be the same, order by sales descending from the highest to the lowest. So now the data is as well sorted already. Let's see how SQL gonna go and assign the ranks. As usual, the first row gonna be the rank number 1, the second as well, but again here we have the same values. So we have same values and it's like the rank, it's gonna go and share the same rank. So both of them gonna have the rank number 2. And now you might say, well, this is very similar to the rank function, so why do we have dense rank? I'm gonna say wait for it. We're gonna have the difference in the next value. So SQL gonna come over here. This value is exactly after the tie. In rank, SQL went and took the position number. So the row number, it was 4, right? So 1, 2, 3, 4. But this time with the dense rank, SQL will not leave gaps in ranking, so there will be no skipping. The next rank in the sequence gonna be 3. So that's why we're gonna have the rank 3 for this value. So as you can see, there is no gap. We have 1, we have 2, and 3. So we are not skipping, we are not leaving any gaps. And the last one gonna be 4. So this is exactly the difference between the dense rank and the rank. So now by checking the output of the dense rank, you can see that we don't have unique ranks. We have here shared ranks. As you can see, we have here repetition. So it handles the ties, and as well, it doesn't leave any gaps. It doesn't skip anything in the ranking. Okay, so that's it. Now let's go back to SQL to practice the dense rank. Alright, so now we have the same task, rank the orders based on their sales from highest to lowest. So we're gonna do the same stuff, but this time using the function dense rank. So dense rank is gonna be empty, and then we're gonna define it like all others over order by sales disk, and then we're gonna give it the name of sales rank dense, and that's it. So as you can see, all of those functions having the exact syntax, right? So let's go and execute it. Okay, so now let's go and check the results. We got our newest rank using the dense, and by just checking the results, you can see that it handles the tie. We have two twice, right? So let's check the example over here. We have the sales 60 twice. That's why they are sharing the same ranking in the dense and as well in the normal rank. But now what is interesting is the value after the tie. So as you can see over here, with the dense rank, we have 3. So we didn't skip any ranking. We don't have any gap. 1, 2, and then 3. But with the rank, it's just focus on the position number. So it is the row number 4. That's why it's 4. With that, we have a gap. So as you can see, now we don't have any gaps in the dense rank. So we have 3, 4, 5. And now we have over here the same two values. So we have sales of 20, 20, and they share the 6 twice. So as you can see, there is difference now between the dense and the rank. So here we have 7, 7, but here we are at the rank 6, 6. So that's why we have differences between them, because we skipped before in the rank number 3. Now the other stuff you can see, we have 7 and 8. So now if you compare those 3 ranking, you can see that they all start with the rank number 1, but they didn't all end with the same ranking. So the row number and the rank, they really focus on the position number or the row number of the orders. So you can see over here, it is the row number 10. That's why we have here 10 and 10. So the scale is from 1 to 10, and that is exactly the same for the row number from 1 to 10. But with the dense over here, we have it from 1 to 8, and that's because we shared the same ranking, and with that we wasted, let's say, few ranks. So the scale is different from the two others, and that's because we have ties twice. This is one tie, and as well we have over here one tie. That's why we are missing over here 2 ranks. So this is how the dense ranks works, and you can go and compare now all 3 together in order to understand how those ranks are working. Alright, so now let's quickly compare the 3 functions side by side. Let's start with the first point about the uniqueness of the rank. And if you compare those 3, you can see that only the row number generates unique distinct rank. So this is going to be unique rank, and the 2 others, we have duplicates, or let's say shared ranks. Okay, so now the second point, whether the function handles the ties, and the only one that doesn't handle the ties is the row number. So this one doesn't handle the ties, and the 2 others handles the ties since they offer the shared rank. And now we have the last point about leaving gaps or skipping ranking. So now if you check the row number and the dense rank, you can see there will be no skipping. So there is no gaps for the row number and as well for the dense rank. Only for the rank function, the middle one, we are skipping ranks and we are leaving gaps. So that's it, guys. This is the differences between those 3 functions. I tend usually to work with the row number more often than the 2 others. Alright guys, so now I had a look to those 3 functions and I checked my projects, real projects, and I found out that there are many use cases for the function row number compared to the other functions, dense rank and rank. So now what we're gonna do, I'm gonna show you a few use cases for the rank number that I usually use in my real projects in order for you to understand how important is the row number function. So let's go to SQL. Alright, so now let's start with the first use case, and we have the task of find the top highest sales for each product. So this is very classic. In reporting or data analysis, we call this top-in analysis. So here the managers or decision makers, they would like to have the best performers or the best success in our data. So for example, the top highest 5 customers or the top 5 products or categories and so on. So this is very important analysis in order to focus on the best products or onto the most important customers and so on. And this is, as I said, very classic and very important in order to make decisions in the business. So now let's see how we can solve this. So we're going to start with the usual stuff. Let's first select the data. So select order ID. Let's take as well the product ID and the sales from sales orders. So let's go and execute this. And now, as we know that for each product we have multiple orders and we have multiple sales, but we are interested only in the highest sales for each product. So we have to go and create a rank. In order to do that, we're going to use the row function, row number, and we have to define the window now. So do we need partition by? Check the query. So it says for each product. That means we have to divide the data by the product ID. So let's go and use the partition by products ID. And now we must use the order by. So order by. And now how to sort the data? By the sales, right? And it is from the highest to the lowest. So let's go sales. And we have here descending. So from highest to lowest, let's go and give it a name. So you're going to be rank by products. So let's go and execute this. And now by looking to the result, you can see that SQL did divide the data by the product ID. So we have here like around 4 windows. The first one over here, you can see that the rank starts from 1, ends with 4. So the highest rank can be the order number 8 with the sales of 90. And then it goes to the 4. Now, as you can see that the second window, we have a new ranking. So it resets. The first gonna be the order number 10 and the last one gonna be order number 2. So as you can see, each window has its own ranking. And as well, the last one, we have it only as 1 row. So now, of course, in the task, we have to return the highest. So we are not interested in the others. We have to return this row as well, and this one and this one. So as you can see, we have to return everything that has the rank 1. We are not interested in the rank 2, 3, 4, and so on. So we would like to have the highest. So now in order to filter the data, what we're going to do, we're going to go and use subqueries. So select star from, and then we're going to have the following condition. So where, and we're going to say rank by products equals to 1. So we are interested only on the rank number 1. So let's go and execute it. And with that, since we have 4 products in our data, we're going to have only 4 rows and we have the highest sales. So as you can see, we have only number 1 over here, and those sales are the highest for each product. And with that, we have solved the tasks by finding the top N analyzes. Okay, moving on to the next use case, we have the following task and it says, find the lowest 2 customers based on their total sales. So now we have the exact opposite use case. We call it button N analysis. So now in this example, in the business, the decision makers want to optimize the costs, want to cut costs. And with that, they have to analyze the lowest performers in the product or the lowest performance in the employees in order to cut costs. So now with this analysis, the decision makers are not focusing on the best successful stuff. We are focusing on the lowest stuff, the lowest performers. So now let's solve these tasks. So now if you check the question, we have multiple stuff, right? We have the total sales, and as well, we have to find the lowest 2 customers. So we have ranking and as well aggregations. Remember, we can do stuff together with the group by. So now let's do it step by step. First, let's select the data, right? So what do we need? Order ID, customer ID, and we need the sales from sales orders. So let's go and execute this. So now if you check the customers over here, we have around 4 customers and they have multiple sales. Now we would like to have the total sales for each customers in order to find the lowest 2. So let's start first with the aggregations. So what we're gonna do, we're gonna go and aggregate the sales. So the sum of sales, let's call it total sales. And now in order to do the group by, we have to have only the customer. So group by, and we have the customer ID. So it is very simple group by statements. Let's go and execute this. So now by checking the result, we can see that SQL did aggregate the data. We have 4 rows, and that's because we have 4 customers and we have their total sales. So we have solved the first part of the task. We have the total sales for each customers. Now let's move to the second part. It says lowest 2 customers. That means we have to use the ranking functions in order to rank those customers. So we are not interested in all customers, we are interested only in the lowest 2. So in order to do that, now we're going to go and use the window function, row number, so, and then over. Now, do we have to partition the data? Well, no, we don't have to do that. We have now to sort the data, so order by. So this time we're going to go and use the aggregations in the order by, so the sum of sales, and we want to have it sorted from the lowest to the highest. So I'm just going to go and use the defaults. So it is ascending. Now let's call it rank customers. So that's it. Again, here the rule is that if you are using a window function together with the group by function, you have to use only columns that is used in the group by. So this should be working. Let's go and execute it. So now, as you can see in the results, we got an extra column for the rank. So now the lowest customer going to be the customer number 2, the second one going to be 4 with the 90 total sales, and the highest customer with the sales going to be the last one, the 125 customer number 3. So now we have almost everything, but the list should contain only the last 2. So in order to do that, to filter the data, we're going to go and use subquery. So select star from, and then we have to define the condition where rank customers, it should be smaller or equal to 2, right? So with that, we will get the first 2. So let's go and execute this. And with that, we got the lowest 2 customers based on their total sales. So customer number ID 2 and the 4. So that's it. We have solved the task, and now we have done button in analysis. Okay, let's keep moving to the next use case, and we have the following task. It says assign unique IDs to the rows of the table orders archive. So now guys, we might be in a situation where you have a table without any primary key and you would like to create an ID for each row. So in order to do that, we can use the function row number in order to generate unique identifier IDs for each row inside our table if we don't have one. And generating such ID for each row, it's very important to do stuff like importing data, exporting data, maybe joining tables as well using this ID, or let's say optimizing the performance of query using the ID. So now let's see how we can generate that using row number. Okay, so now let's first select the table order archives in order to understand the content. So select star from sales orders archive. So let's go and execute. So now by checking the result, you can see that we have 10 orders and we have repetitions in the order ID over here. So it is not really a primary key. As you can see over here, we have twice the ID 4 and here we have 3 times the ID 6. So now what we're going to do, we're going to go and generate unique identifier for each row. So in order to do that, what we're going to do, we're going to go over here and say row number. And then we're going to define the window function. We don't partition the data at all, but we have to sort the data by the order ID. So order by order ID, or you can use something else as well using the order date or something, doesn't matter. So let's add to it order date as well. And let's call it unique ID. Let's go and execute this. Now by checking the data, you can see that we have a new ID over here that comes from the row number, and we have like a unique identifier. As you can see, we have 10 rows, and with that we have as well 10 different distinct unique IDs. So with this, as you can see, we have solved the task and we have now a unique identifier, an ID for the table orders archive. So now having this ID, we can do many stuff like joining tables or doing something special and important called paginating. Imagine we have like a huge table and we would like to retrieve the data. So now in order to not have all the data in one go, we can go and divide the data by the primary ID or by unique identifier. For example, we can make a page from 1 until 100,000, and then the second page starts from 100k to 200k. So now by dividing the data, we can maybe improve exporting or importing data, or we can have faster retrieval for the users. We don't want to have the whole data in one go, in one page. So it has a lot of benefits using paginating, and we can do that only if we have a nice ID like this. Alright, so now I'm going to show you the last use case for the function row number that I usually use in my real projects. So sometimes if you are doing data analysis, you're going to find out that there are data quality issues, especially with the duplicates. So what I usually use, I use the row number in order to identify the duplicates. Not only that, I can use it in order to delete the duplicates. So we can use it in order to do data cleansing, and this is essential task for each data engineer, not only data analysts, in order to prepare and clean up the data before doing data analysis. So let's have the following task. Identify duplicate rows in the table orders archive and return a clean result without any duplicates. So not only we have to identify the duplicates, we have to return no duplicates in our results. So let's see how we can do this. Let's first select the data. So select star from sales orders archive. So let's go and execute. So now by looking to the data, you can see that we have duplicates. We have an issue. So the order ID number 4 is twice in our database. It doesn't make sense, right? It should be only one. So which one is the correct one? If you check the data over here, you can see that this order is shipped and then delivered. So it looks like the last one is the correct one. So how we can do that? If you just scroll to the right, you can see that we have a creation time, and we usually use such a timestamp in order to identify what was the last valid order. And here we can see immediately that this order time is higher than the previous one, which means this is the more up to date, right? The more current. So what we're gonna do, we're gonna go and rank our data for each order ID and sort the data by the creation time in order to find the last inserted or created row for this order. So let's see how we can do that. What we're gonna do, we're gonna go over here and say, let's have a row number, and then over, and what we're gonna do, we're gonna partition by the primary key. So partition by order ID, and as we said, we have to order the data by this timestamp at the end. So partition by or order by creation time and descending. So we want the highest, then the lowest. So that's it. Let's call it rn and execute the query. So now by checking the data, if everything is clean and we don't have duplicates, everything should be 1, because maximum for each primary key we should have 1 row. So but you can see over here we have here 2 and we have here 3, 2. So that means this is indicator that we have duplicates inside our data. So now by checking one by one, as you can see, the order ID is only 1. So we have the rank 1, the second one as well, we have the rank 1, but here we have the issue. So as you can see, we have now 2 ranks for the order ID 4. So now which one is the correct? In our logic, we said it is the last row that is inserted inside our data, and this is rank number 1. So if you scroll to the right side, you can see that the creation time here is higher than the second one. So with that, we have identified what we want. We want the last inserted row for each ID. And now let's check this over here. So here we have it 3 times. So it says the first one is the highest creation date. So if you go to the right side, and now by comparing those timestamps, you can see that this record, the first one, is the latest one that is inserted inside our data. So as you can see, this one is the one that we need. The other 2, we don't need it because it is old informations. So now everything that doesn't has the rank number 1 is not valid. It's something old and it's actually bad data quality. So we want to remove it or not to select it. So now in order to have a clean data, what we're gonna do, we're gonna go and select the following as subselect. So select star from the table. And now we are interested only with the rank number 1. We don't need anything else. So let's go and execute. And now if you check the results, you can check the order ID over here. It is unique. We don't have any duplicates, right? 1, 2, 3, 4, 5, 6, 7. There is no duplicates at all. And we have now only the latest inserted data inside the orders, and we don't have any duplicates or data quality issue. So now, of course, now we can go with this result in order to do further analysis. And this is exactly what data engineers usually do. Clean up the data and prepare the data before doing any data analysis. And of course, if you want to communicate those data quality issues to the source of the data, let's say you are not the owner of those informations, you can generate a list of all bad data quality issues and you can send it to the source system and tell them to clean it up from the sources. So now in order to select the bad data, what we're going to do is we can just change here the condition and say if it is higher than 1, then you are like bad data. So let's go and execute this. And now with this, we have in the results all records that shouldn't exist in the data in the first place. So we can go and export it and communicate it to the source and tell them, check here, you have something wrong in your system and those informations should not be inserted in the data. So everyone, it is very strong, right? It is very powerful. I use it a lot in my projects. There are many use cases for the row number function in SQL. We can do it in order to find the top n analysis, the bottom n analysis, the best performance, worst performance, and as well we can assign unique IDs to do paginating, or we can use it in order to discover data quality issues to clean up our data. So it is amazing function in SQL and you're gonna use it a lot. So that's it for the 3 functions, row number, rank, and dense rank. Now we're gonna talk about the NTILE. Okay, so what is NTILE? NTILE in SQL is very simple. It's gonna go and divide your rows, your data, into specific number of almost equal groups, or sometimes we call them buckets. So now in order to understand this and how SQL works with this function, we're gonna have a very simple example. So let's go. Okay, we have the following setup. We have 4 rows, 4 cells, and we would like to divide it into 2 groups or into 2 buckets. So in order to do that, we can use the NTILE function. It has different syntax than the other ranking functions. So it starts with NTILE, then we must define a number. So we cannot leave it empty like the other ranking. So here we have 2 buckets, then over, and here again we have to sort the data, so it is must. Order by cells, descending from the highest to the lowest. So now as usual, SQL gonna go and sort the data. We have it already sorted in this example. Then it's gonna start assigning each of those rows into buckets. But SQL first has to calculate the bucket size, so how many rows we can insert inside each bucket. So the calculation is very simple. It says the bucket size equals to the number of rows divided by the number of buckets. So what is the number of rows here? We have 4 rows, right? So we have 4 over here. Then the number of buckets, we define it in the syntax of the query. So here we defined 2 buckets. We need 2 groups. So that means we are dividing 4 by 2, and the size of the bucket is going to be 2. So now with this, SQL is ready and going to start assigning each row to a bucket. So it's going to start on the top. The first one going to be in the bucket number 1, then go to the next one. It's going to say, okay, we still have enough space in the bucket, right? So it's going to assign it as well to 1. But with this, we reach the maximum number of rows within each bucket. So the next row going to be assigned to another bucket. So it's going to be 2. And the last one going to be as well 2. So as you can see, it's very simple. We have just assigned our cells based on the sorting, of course, into 2 buckets. These 2 cells belongs to the bucket number 1 and the other 2 belongs to the bucket number 2. Very easy. So that was very straightforward because we are dividing even numbers and we got perfectly sized buckets. But now what can happen if we have an odd number? So we have here 5 instead of 4. So the bucket size going to be dividing 5 by 2. We're going to get 2.5. And now, of course, SQL will not go and divide like 2 halves for each bucket. Then we are splitting this into 2 buckets. Of course, this will not be working. We should have now a bucket with 3 and another bucket with 2. So now the rule in SQL make it very clear. It says larger groups comes first, then smaller. So that means if we have here an even number like this, the larger group going to be the first group. So that's gonna look like this. It's gonna reset everything. So let's see what's gonna happen. The first one gonna be 1. The second one as well 1. The third one gonna be as well 1. So it gonna has a larger bucket than the second one. Then the rest gonna be 2. So as you can see, the larger group comes first, then the smaller. And this is how SQL gonna work if you have odd numbers. So you don't have here perfectly sized buckets. You have approximately or roughly equally sized buckets. So this is how the NTILE works. Now let's go back to SQL in order to practice this function. Okay, so now let's have some fun working with this function. So we're just gonna select something like order ID, sales, from, sales, orders. So let's go and execute it, and with that we got our 10 rows. Now let's say that I would like to create only 1 bucket from the data. So NTILE and only 1 bucket over partition. Let's say not partition by, let's take order by sales descending. So that's it. I'm gonna call it 1 bucket. So let's go and execute it. As usual, SQL gonna go and sort the data and then calculate the bucket. It's gonna be 10 rows divided by 1. So the size of the bucket gonna be 10. So that's why you're gonna see everywhere here as a 1 because all those rows gonna fit into 1 bucket. So this is very simple. We have only 1 bucket. Let's go and now have 2 buckets. So I'm just gonna copy and paste, and instead of 1 we're gonna have 2, and let's call it 2 buckets. So let's go and execute this. So now here again, what is the size of the buckets? It is 10 divided by 2. So we will get perfectly grouped buckets. So the first bucket gonna be 5 rows and the second one gonna be the next 5 rows. So it is very perfect. Let's go to the next one. Let's have 3 buckets. So 3. So let's go and execute. So now what's gonna happen? SQL gonna go and divide 10 by 3. in order to get the size of the bucket, and it's gonna be 3.3, so it is decimal, and we will not get perfectly sized buckets. So again, the larger group comes first, and then the smaller. So as you can see, we have to fit then in the first group 4 in order to get the others with 3. So that's why the first bucket is gonna be the biggest one. So 4 rows into the first bucket, then the second 3 rows gonna be in the bucket 2, and as well the last one gonna be bucket 3. So as you can see, the larger group is gonna be the first bucket. So now let's keep playing with the data. Let's go and take now 4. We would like to have 4 buckets. Now things gonna get interesting. So now by checking the results, gonna be interesting. SQL gonna divide 10 by 4 and we will get something like 2.5. So again, we will not get perfectly sized groups. So SQL has to fit now 10 rows into 4 groups. So the first 3 rows gonna be fit in the bucket number 1, and as well the second 3 rows like this gonna be in the bucket number 2. And then you can see over here we have 2 buckets with the size of 2, and with that we can fit 10 into 4 groups. And again, you can see the larger groups comes first, like this one, and then the second, and the smallers comes later. Okay, so this is how the enter works in SQL. And now you might say, you know what, why do I need buckets in the first place? So what is the use case? There is 2 use cases for the NTILE function in my project. In one hand, if I am data analyst, I'm going to use the NTILE function in order to segment my data. In the other hand, if I'm data engineer, I'm going to use the NTILE function in order to do ETL processing and as well to do load balancing. So now let's start with the first use case as a data analyst, where you want to do segmentations with the NTILE function. Segmentations is a very nice way in order to understand your data. So you can go and segment your data into different buckets or groups, like for example, doing segmentations for the customers. So you can go and group up your customers depend on their behavior, like the total sales or the total number of orders. So with that, you can make, like for example, VIB section, and then the medium, and then the low. So now in order to understand the segmentation use case, let's have the following task. Okay, the task says segment all orders into 3 categories: high, medium, and low sales. So in order to solve this, let's do the basic stuff, right? So select order ID. Let's take the sales from our table, sales orders, and let's go and execute it. So as usual, we got our 10 sales. So now if you check the task, it says we need 3 categories. So that means we need 3 buckets, right? And it says high, medium, and low sales. So that means we are dividing by the sales. So let's go and do it step by step. So we're going to use NTILE since we need to segment the data. 3 categories means 3 buckets. And then let's define the window over. We don't have to divide the data by partition by. We just need to sort it first by the sales. So it's going to be by sales, and let's take discrete since we want to sort it from the highest to the lowest. So that's it. Let's say you are our buckets. So let's go and execute this. So now if you check the data, you can see that they are segmented into 3 buckets. So the first bucket is going to contain all orders with the high sales. Then the second one going to be all sales with the medium. And then the last one going to be all sales with the low sales. So as you can see, we have already categorized our data into 3 groups. But now as you can see, we have numbers. And maybe the user is expecting to have those text, high, medium, low. So that means what we're going to do now, we're going to go and translate those numbers into text, into words. And of course, we cannot do that inside the window function. We're going to use data transformation using the case when statements. Don't worry about it. We're going to have a complete dedicated section explaining the case when. So for now, just follow me in order to see how this works. We're going to go and use subquery. So it's going to be select. And let's take the star for everything, and then let's have the following logic. Case when buckets equal to 1, then it is high. The sales is high. So we are just mapping the numbers into text. So otherwise, case when the buckets equal to 2, then we are targeting the medium, and then the last group, buckets equal to 3, then those sales are low. So let's call it end it, and let's call it sales segmentations. So that's it. Let me just make it a little bit smaller in order for you to see it. And all right. So from, and then we have our subquery like this. So as you can see, we just mapped the numbers into text. We are just doing translations. So let's go and execute it. And now by checking the results, we got our 3 categories for the users. So the first category is going to be the high sales, the second one going to be the medium sales, and the third one going to be the low sales. So guys, you see, NTILE is very powerful in order to segment our data. So now you can go and segment stuff like the customers by their total sales, or the products by prices, employees by their salaries, and so on. Alright, so this is the first use case for the NTILE function as a data analyst, where you go and segment your data in order to understand the behavior. Now, in the other hand, if you are a data engineer, you can use NTILE function in order to do load balancing in your ETL. So now I'm just going to explain it in very simple sketch. Alright, so now we have the following scenario where we have 2 databases and we would like to move one big table from the database A to database B. So in this case, I'm doing something called full load. That means I'm loading all the rows from one database to another. So if you do it in one go, what could happen is that it could take a long time. So it could take hours or even sometimes days. And maybe at the end you will get maybe some network errors because you have stressed the networks between those 2 databases, and everything gonna break and you're gonna lose the data and you have to start again. So now instead of loading this table in one go, what we can do, we can go and split it into fractions, or let's say buckets. So we can split this table, for example, into 4 small tables using the function NTILE. So now after we split this big table into small tables, we can go and start moving those small tables one after another, and with that we are not stressing the networks and it's gonna succeed. So now after loading everything at the end in the target database, we're gonna have those small tables, and of course we can go and use the union in order to merge them in order to have again the big table that we have it in the original database. So this is very common use case for the NTILE in order to split the load and to balance the processing of extracting data. Alright, so now we have the following SQL task. It says, in order to export the data, divide the orders into 2 groups. So let's go and do that. First, we can select everything from the table, just in order to see the data, sales, orders. So let's go and execute it. So now we got our 10 orders, and what we have to do is that to go and split it into 2 groups. In order to do that, we can use the NTILE function. 2 groups means 2 buckets. So let's define the window. So here we don't have to partition the data using partition by, but we have to specify the order by. So now which column we're gonna use in order to sort the data. Of course, here there is no rule, like you can go and split the data by sales or by the order status, by date, by anything you want, but we usually go and use the primary key. It's just systematic, better and more clean, especially if you have a sequence of numbers in the order ID. So you can export the first range of the orders, then you can go to the next group and so on. So let's go with the order ID and let's give it a name, buckets. So that's it. Let's go and hit execute. Now, as you can see, it's very simple. We got our 2 groups. So this is the first batch of the data, and this is the second batch of data. So now we can go and select the first batch and export it, import it in the next system, and then after that we go with the second batch. And of course, if you still suffer from the size of those buckets, you can go and split it to more smaller size. So you can go over here and make it 4. So with that, we're gonna get smaller buckets, and it might be easier to export the data. So this is really great use case for the NTILE function. Alright everyone, so with this you have learned the 2 use cases for the NTILE function that I usually follow in my projects. So as a data analyst, you can use it in order to do segmentations, and as a data engineer, you can use it in order to do load balancing of the ETL. Okay everyone, so with that we have covered everything about the integer-based ranking functions. Now we're gonna talk about the second methods. We have the percentage-based ranking functions, and here we have 2 functions, the cubedist and as well the percentile. So now let's have a quick recap. So with the percentage-based ranking, SQL gonna go and calculate a relative position as a percentage and assign it for each row. So the output gonna be a continuous normalized scale from 0 to 1, and this is really amazing in order to do distribution analysis. So those functions gonna consider in their calculation the overall total, the whole size of the dataset, which can help us in order to find out the contribution of each value to the overall total. And now in SQL, in order to generate the percentage, we have 2 different formulas. So in one hand we have the function cumdist, and in the other hand we have the percent rank. So that means we have 2 different functions with different formulas in order to generate and calculate the percentage. So now let's start with the first function, the cumdist. Alright everyone, so now let's start with the first function. We have the cumdist and it stands for cumulative distribution. It's gonna go and focus or calculate the distribution of your data points within a window. So what this means, in order to understand it, we're gonna go and have a very simple example to understand how SQL works with this function. So let's go. Alright, again we have our very simple example of the sales and we have the following query. So cumdist, then we don't give any argument inside it, so it's gonna be empty, and the window gonna be like usual, order by sales, descending from the highest to the lowest, and the order by is must. So the first step, SQL gonna go and sort the data. We have it already sorted from the highest to the lowest. So now the next step is that SQL gonna go and start calculating the percentage for each row, and we have a very simple formula. It says the cumdist equals to the position number of the value divided by the number of rows. So now the next step, SQL gonna go and start calculate the percentage for each row, and we have this very simple formula. It says the cumdist equals to the position number of the value divided by the number of rows. It's very simple. Let's do it step by step. So SQL gonna start with the first value in our list. So it's gonna be calculated like this. So what is the position number of the first value? It's gonna be 1, right? So this is the first value in our list. And what is the total number of rows? We have 5 rows, right? So 1, 2, 3, 4, 5. So we're going to divide 1 by 5 and the result is going to be 0.2. So this is going to be the first value for the first row. Okay, so now SQL going to go to the next row, and this time we're going to get a special case. As you can see, we have the 80 twice. So we have here a tie. So now first we need the position number. As you can see, we are at the position number 2, right? But since we have the 80 multiple times, SQL gonna go and take the last position that we see the value 80, and the last position gonna be the record number 3. So that's why SQL gonna say for this record it's gonna be the position number 3 and not 2, and then it's gonna go and divide it by 5 and we will get the value of 0.6. So this is the most confusing thing with this function. So if SQL finds a tie, it will completely ignore the current position number, so we don't have 2. It's gonna go and take the last position number for the same value, and the last in our list gonna be the record number 3. So that's why we have 3 over here. Okay, so now let's keep moving. Let's go to the third row, and as you can see, we are again in the tie, but this time this is the last time we see 80. So next we don't have 80. So what's gonna happen? We're gonna have exact same results. So it's gonna be 3 divided by 5. So as you can see, if we have a tie, they're gonna share the same percentage. So that means with the cumdist, if you have same values, they're gonna share the same rank. So let's keep moving to the fourth one. So now what is the position number of the 50? We are at the record 4. So position number 4 divided by 5, we will get 0.8. Okay, so now let's move to the last one, and it is the easiest one. So which position do we have over here? It is the position number 5. It's the last one, and the number of rows is 5. That's why we will get 1. So guys, that's it. This is how the cumulative distribution works. Once you understand the formula, it's going to be very easy in order to understand the output. So as you can see, calculating the percentage always depends on the total size of our data sets. You can see here the number of rows. So with this, we're going to get an output that helps us in order to understand the distribution of our data points within the data sets. Alright everyone, so now we're going to go and focus on the second function that generates percentage as a rank. We have the percent rank. So the percent rank going to go and focus on generating the relative position of each row within a window. So in order to understand what this means, we can have a very simple example in order to understand how SQL works with this function. So let's go. Okay, again we have those sales, very simple example, and the syntax is going to be like this. Percent rank, and inside it we don't use any arguments, and the window gonna be like this. Order by, it is a must. Sales descending from the highest to the lowest. The first step that SQL gonna do is that's gonna go and sort the data from the highest to the lowest, and we have it already like this. And next SQL gonna go and start calculate the percentage, which is very similar to the cumulative distribution, but this time it's gonna be like this. Position number then we subtract it from 1, and as well divided by the number of rows subtracted from 1. So it's like exact formula, but we are only subtracting here once for both numbers. Okay, so now let's go through all rows step by step and see the output. So SQL gonna start with the first row, right? So what is the position number of the first row? It's gonna be 1. Then we have to subtract it by 1. That's why we will get 0. Now what is the total number of rows? We have here 5 rows, and it is subtracted by 1. That's why we're gonna get 4. So now 0 divided by any value, the output gonna be a 0. So that's why for the first value we will get a 0. Alright, so now let's move to the second row over here, and here we have our special case where we have a tie. So we have two cells sharing the same value 80. So now for the percent rank, SQL gonna have different behavior than the QM dist. Remember in the QM dist, SQL did search for the last position of the shared value. So it was the position number 3, since this is the last time we see 80. But now with the percent rank, SQL gonna stick with the first occurrence of the shared value. So now by checking those two 80s, what is the first occurrence? It is the record number 2. So that's why we have position number 2 subtracted by 1, we will get 1, and here the same gonna be number of totals. We have 5, subtract by 1, we have 4. So now if you divide 1 by 4, we will get the result of 0.25. So this is the percentage of this value. So now let's go to the second row. Here we have again the tie. So SQL gonna stick with the position number 2, the first occurrence. So it's gonna be the same. 2 subtracted by 1, we will get 1, and as well the total number of rows, 5, subtract by 1, we will have 4. That's why we will get the same exact results. So here as you can see, with the percent rank, it's like the QM dist, the shared value gonna share as well the same percentage rank. Now let's move to the fourth one. So we have the value 50. So what is the position of this? It's gonna be the record number 4, subtracted by 1, we will get 3, and if you divide 3 by 4, you will get 0.75. And now moving to the last value over here, it's gonna be easy. So what is the position number of the 30? It is 5. 5 subtracted by 1, it's gonna be 4, and as well we're gonna have 4 as well here for the total numbers subtracted by 1. So if you divide 4 by 4, you will get 1. So that's it, guys. This is how the percent rank works. It always has the scale from 0 to 1. So it's always like this. It doesn't matter which values do we have inside, and it's gonna have like a continuous scale. And again here, if you have a tie, they're gonna go and share the same percentage rank. Okay guys, so now if you go and compare those two functions, you can see that they are really similar to each other's. The output of both functions, we are generating percentage based ranking, and both of them as well handling the ties perfectly, so they share the same percentage rank. If you check the syntax, they are very similar. And now by checking the formulas of both of them, we are always considering the overall size of the data sets. So here the size is considered in the calculation to help us finding the relative position of each value to the overall. And this is very important in the analysis in order to measure the contribution of each value to the overall. So now about the use cases, if you want to focus on the distribution of your data points, go with the cumulative distribution. But if you want to focus on the relative position of each rows, then go with the percent rank. Alright, so now there is one more difference between the QM dist and the percent rank, and that's if you check the formulas, you can see that the QM dist is more inclusive. We always consider the position number of the current row, but with the percent rank, we don't consider the current row, we like skip it or make it exclusive. So we say for the percent rank, it is more exclusive, and the cumulative distribution, it is more inclusive. So now if you ask me the hard question, which one to use, I'm gonna say if you want to be more inclusive, go with the cumulative distribution. If you want to be more exclusive with the current row, go with the percent rank. So they are very similar to each other's. So if you want to calculate the distribution of your data, go with the cumulative distribution. If you want to find the relative position of each row, then go with the percent rank. Alright, so now we have the following task. It says find the products that fall within the highest 40% of the prices. Let's go and solve this. Now we are targeting the table products, and I will just select like two columns: product, price, from sales, products. So that's it. Let's go and execute this. So now as you can see, we got 5 products and their prices, and the task says find the highest 40%. So we have to find and generate a percentage rank. In order to do that, we have the two functions, QM dist and the percent rank. I will go this time with the QM dist. So let's go and do that. So QM dist, and then let's go and define the window like this. It's gonna be order by. We are targeting now the prices, right? So order by the price from the highest to the lowest, and let's go give it a name, dist rank. So let's go and execute this. So now with that, SQL gonna go and generate for us a percentage ranking using the formula that we just learned before. So now in the output we are getting all the products, but the task says we have to get only the products that are in the highest 40%. So that means the first row, the second row, and that's it. So those rows are in the highest 40%, the rest are below that. So in order to do that, to filter the data, we're gonna use the subquery. So select star from, and then we have our subquery like this, and then our filter gonna be dist rank smaller or equal to 0.4. So this is our threshold in order to get the data. So let's go and execute this. And now as you can see, we got the top products, the top 40%. Now of course you can go and format the percentage. We can do that like this. So let's take the dist rank, multiply it with 100. So let's go and execute this. So now as you can see, we got 20 and 40%. We can go and add to it as well the percentage character, right? So we can go and say concat, and we're gonna add the character after that like this, and let's call it dist rank percentage. So that's it. Let's go and execute it. So that we have solved the task, we have the products that fall within the highest 40%. Now of course you can go and try the percent rank. So it's very simple. We just have to go and switch the cumulative distribution with the function percent rank. So let's go and execute it. Now as you can see, we will get the exact same results. So we're still getting the gloves and caps as the highest products within the 40% of the price. So guys, that's it. It's very simple, right? Alright friends, so now let's have a quick recap for the window ranking functions. So what they're gonna do, they're gonna go and assign a rank for each row within a window. And we have two types of ranking, right? The first one is the integer based ranking. It's gonna go and assign a number, an integer for each row. And here we have four functions: row number, rank, dense rank, and NTILE. And the second type of ranking, we have the percentage based ranking. So SQL first gonna go and calculate a rank and then assign it for each row. And here we have two types of formula or functions. So we have the cum dist, the cumulative distribution, and the second one we have the percent rank. And now to the next point, if we are talking about the rules of the syntax, so the expression should be empty. We should not pass any argument to the functions. We must use order by in order to sort our data, so it is required. And the frame clause are not allowed to use, so you cannot go and customize a frame within the window function. And as we learned, there are many use cases for the ranking functions. For example, we have the top in analyzes, the bottom in analyzes, in order to identify our top performers or the worst performers in our business. Another use case, using the row number, we can identify and remove duplicates in our data, so we can use it in order to find data quality issues and as well to improve the quality. And another use case, if our table don't have a clean primary key, we can go and generate unique IDs using the row number in order to do as well paginating. One more use case, it was the data segmentations. You can use the NTILE in order to segment your customers, your products, employees, and so on. And another use case, we can do data distribution analysis. As we learned, we can use the cum dist in order to understand the data distributions of our data points compared to the overall. And the last use case, it's more for data engineering. We can use the NTILE function in order to equalize the loading process of our ETLs. So as you can see, there are many use cases for the ranking functions. Alright, so with that you have learned how to rank your data using 6 different SQL window functions and their use cases. They are amazing for data analytics. Now moving on to the next one, we have the last group of window functions. We have the value functions. They are, my friends, the most important group for data analytics compared to the other two. So here we're going to focus on 4 functions. We're going to learn how SQL works with that, the syntax, and as well the use cases. Alright everyone, so now we have this very simple example. We have the months and the sales. Now we can use the value functions in order to access a value from another row. So in order to understand it, let's say that SQL now processing the months and we are currently at the month of March. So now for example, I would like to access the value from the previous month, from February. So in order to do that, we can use the lag function in order to get the value of 10. So with that, we have in the same row the current sales of the month March and as well the sales from the previous month the February. And maybe in other cases, I would like to get the sales of the next month from April. In order to do that, we can use the function lead, and we will get at the same row the value 5. So now I can very quickly compare the current month with the previous month and as well with the next month. And now in the other cases, you might be interested in the first month of your list. So it's going to be here, January. So in order to get the sales of the first month, you can use the function first value. So we're going to get at the same row 20. And now for the last option, I think you already get it. We can go and get the value of sales of the last month. So here we can get the July. So for that, we're going to use the function last value, and we will get the value of 40. So this is exactly the purpose of the value functions or analytical functions. We can access a value from another rows. And here it's very important to understand as well, the value functions is like the ranking functions. We have to use the order by in order to sort the data, in order to understand what is the first row and the last row. In this example, the data is sorted by the month. So guys, the access functions are really important for analytics. You can use it in order to access a value from other rows in order to do comparison. Alright, so now let's have a quick overview of the syntax and the rules for the value functions. So here we have 4 functions: lead, lag, first value, and last value. So as you can see, we can group them into 2 groups. So we have the lead and lag. They are very similar to each other's, especially with the syntax. We can use 3 things or 3 arguments inside it: expression, offset, default. For both of them, for the first value, we can use only an expression. So that means we have to pass and value for those functions. You cannot leave it empty. So now about the expression data type, you can use any field with any data type. There is no restrictions about only, for example, using numbers. Any data type is allowed. Now about the definition of the window, the partition by as usual is optional like any other group. The order by here is a must. You must define an order by. It's like the ranking. So here you cannot leave it empty. Now we come to the last one. We have the frame clause. They are really different stuff over here. So for the first 2 functions, lead and lag, you are not allowed to define any frame. So you are not allowed to define any subset of data. It's very similar to the ranking. So you must use order by, but you cannot define the frame of the window. But for the other 2 functions, the first value and the last value, they are optional. You can go and use them. And for the last value, it is recommended to define a frame clause. Don't worry about it, we're gonna have enough examples in order to understand. So as you can see, those functions has different requirements, so there is no generic rule for all of them, but one thing that they all agree on, that you must use order by. So now as usual, what we're gonna do, we're gonna go and deep dive into those functions. We're gonna address first the 2 functions lead and lag because they are very similar to each other's. We can understand the use cases, when to use them, and of course we're gonna practice in SQL. So let's go. Lead and lag functions. The lead function can allow you to access a value from the next row within a window, where the lag function is exactly the opposite. It can allow you to access a value from a previous row within a window. It sounds very easy, right? So let's understand how SQL gonna execute those functions. Okay, so now let's have a quick overview of the syntax for both of the functions lead and lag. We have here a very simple example for the lead function. So as usual, we start with the function name. It's gonna be the lead, and now after that we're gonna go and pass the arguments, and as you can see, we have here multiple stuff. So let's do it step by step. So the first thing is that we're going to go and specify an expression, and the data type could be any data type. It could be a number like here, the sales. It could be a character like names or dates or anything. So this is required. We have to specify an expression. We cannot leave it empty, and we can use any data type. Now moving on to the next one, we have here a number. So what is it? This is the offset, and this offset is optional, so you can go and skip it. So what offsets means, what we are doing over here, we are specifying for SQL the number of rows forward or backward from the current row. So here in this example, we are specifying the offset as 2 using the lead, and with that we are telling SQL, go jump to the next 2 rows and get me the value. And if you are using lag, it means you are telling SQL, go back 2 rows up and get me the value. So here you are telling SQL how many rows it needs to jump. And if you don't specify anything, like leave it empty, SQL gonna go and use a 1. So the default of this, so the offset, is gonna be 1 if you don't specify anything. Alright, moving on to the last one and to the third one, this is as well optional. You can go and leave it empty. So here it is the default value. Now what happens with those functions is that sometimes sometimes SQL jump to the next two rows or something like that, and SQL doesn't find anything. So there is no more rows available to access. And with that, SQL gonna go and return a null. So that means if SQL goes to the next rows or go to the previous rows and doesn't find anything, SQL as a default gonna go and return a null. So if you don't specify anything over here, in those scenarios, you will have a null values as a return from the whole function. But in some scenarios, you don't want to have a null. You would like to have a value. So here you are defining the default value. So it should not be a null, it should be a 10. So SQL, if you don't find anything, return a 10. Don't return a null. So again, guys, the default values, the offsets, all those informations are optional for you in order to configure it, but you should know the default. If you don't use anything, for the offset it's going to be 1, for the default value going to be null, but you must specify an expression. So here you cannot leave it empty. All right, so that's all about the arguments that you can pass to the lead or lag functions. Then the next stuff are the standard stuff. So we have the over clause, then we have the partition by. As usual, partition by is optional. And then to the order by, those functions, it's like the rank functions, it requires you to sort the data. So it is a must to sort the data. Otherwise, SQL will not know what is the next row, what are the previous rows. So we have to sort the data. It is required. You cannot skip this, so it is not optional. All right, so the syntax is not crazy, right? We have the usual stuff, but only we can go and configure the default value and the offsets. Okay, guys, now we have a very simple example. We have months and sales, and we're gonna go and understand how the SQL works for both of the functions, lead and lag, side by side. So now in the first example, we are interested in the sales of the next month. So in order to do that, we're going to use the lead function. So lead, and then we're going to specify the argument. It is the sales. We want the value of sales. And then we define the window like this, order by month. So it's going to be ascending. And now in the right side, we're going to be interested in the sales of the previous months. So in order to do that, we're going to use the lag function. So it's going to be very similar to the lead. We have lag and then the sales, since we are interested in the sales, and we're going to store the data by the month. So now let's see how SQL going to do it step by step and side by side. So SQL going to start with the first. So now let's see how SQL going to process those informations side by side and row by row. So it's going to start with the first row over here. What is the next month of January? It is February, and we are interested in the sales of this row. So SQL gonna take the value from the next row, and we're gonna have the value of 10. So now by looking to the January, we can see the sales of the next month of February in the same row. So now let's check the right side over here. Now we are interested in the previous month. So what is the previous month of the first row? It will be nothing, right? So we cannot point it with anything. That's why SQL gonna say this is null. There is no previous month for the current row, and we're gonna have it as a null. Okay, so now SQL gonna go to the next row. We are at February. What is the next month? It's gonna be March, and it's gonna point to it. So we will get the 30 as the sales of the next month of March. And on the right side, what is the previous month of February? It's gonna be January, right? So it's gonna get the value, the sales of the previous month, and here we will get 20. So as you can see, it's very simple. On the lead, we are always checking the next values. On the lag, we are always checking the previous value. So let's keep going. We are currently at March. What is the next month? It's going to be April. So SQL going to go and point to it like this, and we will get the sales of the next month, April. For the March on the right side, what is the previous month? It is February, right? So it's going to go and point to February. So we will get the sales of 10. And now interesting to the last row over here, you can see that we are at April. What is the next month of April? There is nothing because we are at the end of our table, right? So since there is no month after that, we will get a null in the output. But for the lag, we still have a previous month for April. So what is the previous month? It is March, and we will get the sales of the March. So it's going to be 30. So that's it, guys. It's really simple, right? It's just like they are doing the opposite things. So now, if you check those values side by side, you can see that with the lead, we will always get a value for the first row, but for the last row, it's going to be always empty because there is no next value. We are at the end of the table. But if you check the lag, for the first value, we will always get a null because there is no previous value or previous record from the first row. And for the last record, as you can see, we're always going to get a value because we will have a previous value. Okay, let's move on in order to understand how SQL this time works with the offsets and the default value. So now we have the same data, but we have different tasks. So now on the left side, we would like to get the sales of 2 months ahead. So it's not the next month, it's going to be 2 months. And we would like to tell SQL, if you don't find any value, don't return null, return for us is 0. So this is going to be our default. Now, if you check the syntax, it's going to be exact like before, but we are adding now an offset of 2 because we are interested in 2 months ahead, and we are specifying here a default value 0. So if you don't find anything, put 0, don't put null. Now on the right side, we have the exact opposite. We are interested in the sales of 2 months ago. So we are not interested in the direct previous month. We need the sales of 2 months ago. And here the same thing. If you don't find anything, don't return null, give us a 0. So as you can see, we have the same syntax, but using the function lag. So now let's understand how SQL can execute this step by step and side by side. So SQL gonna start with the first month, January. So now SQL gonna ask, what is the sales of 2 months ahead? So we are at January, it will not be February, it's going to be the month of March. So it's going to go and point it like this, and we will get the value of 30. So 30 is the sales of 2 months ahead. And now on the right side, we are as well at January. SQL can ask the question, what is the sales of 2 months ago? So we don't have any previous data, right? So we will not get anything. SQL going to return null, but it's going to check, do we have a default value? Well, yes. So this time SQL will not return null, it's going to return the default value, and this time it's going to be 0. Alright, so now let's go to the next value. We are currently at February. What is the sales of 2 months ahead? So it will not be March, it's going to be April. So it's going to go and point it like this, and we will get the value of 5. So now on the right side, we are currently at February. Now the question is, what is the sales of 2 months ago? We have history, we have the previous month, but we don't have 2 months in the history. That's why we will still get 0 at the output with the default value. Okay, so now let's keep going to the next value. We are currently at March. SQL can ask, what is the sales of the 2 months ahead? We have only 1 month after that, but we don't have 2 months. That's why SQL will not find anything, and it's going to return null, but it's going to go and use the default. So here we're going to go and get the value of 0. There is no more data available in the table. But now on the right side, we are currently at March, and we are asking what is the sales of 2 months ago. So now we have enough history in the past, and it's gonna get the value of 20. Alright, so now let's go to the last month over here in our table, April. What is the sales of 2 months ahead? We don't have any data, so it's gonna be 0 as well. But now on the right side, we are currently at April. What is sales of 2 months ago? We have enough history. That's why SQL gonna get and point it like this. So we will get the February, gonna be 10. So that's it. This is how SQL works with the lead and lag using offsets and as well default value. Let's go back in SQL in order to practice those 2 functions. Okay, so now we have the following task, and it says, analyze the month-over-month performance by finding the percentage change in sales between the current and the previous month. So that means we have to go and compare the current month with the previous month. So the main use case for the lead and lag is to do comparison analysis, and we have a very common use case. It's called time series analysis. So it is the method of analyzing our business, our data, in order to understand the patterns and trends over the time. And one of the most important and classical questions that you're gonna get from the decision makers or business is to do year-over-year analysis or month-over-month analysis. So the year-over-year analysis is gonna help us in order to understand the overall growth or decline in the performance of our business over the years, over the time. But in the other hand, we have month-over-month analysis in order to do short-term trends analysis and as well discover the patterns in the seasonality. So the main focus is to understand the performance of our business over the time. So now let's go back to SQL in order to solve the task. Okay guys, so now let's go and do it step by step. Now, what is the first step? Before we go and compare things together, we have to collect the data. We have to do the calculations first. So we have to find out first the total sales for the current month and then the total sales for the previous month. And after that, we can go and compare them. So now let's start with the easy stuff. We have to find out the current sales for the current month. So in order to do that, let's just do very simple select. So what do we need? Let's take the order ID. Let's take the order date because inside it we have the month. Let's go and collect the sales. So that's it for now. From sales orders. So let's go and execute this. So now in the result, we got the usual stuff. We have 10 orders, sales, and order dates. But the order date is on the level of the days. And we are not interested on the whole date. We would like to get only the month in order to calculate the total sales for the month. Now we're going to go and use a function in order to extract the month from a date. Don't worry about it. We're going to have a dedicated chapter in order to show you how to deal with the dates format in SQL. So now what we're going to do, we will use a very simple function called month and order date, and let's call it order month. So that's it. Let's go and execute it. Now, as you can see, we got a new field where we have only the month of formations. So here we have January, February, and March. So now the next step is that we want to find the total sales for each month. So what we're gonna do, we're gonna go and use group by. So let's do that. We're gonna go and say we want the sum of sales. I'm just gonna call it current month sales, and let's go and get rid of all those informations. We're gonna go and group by the month, right? So group by, and let's have the month. So that's it. Let's go and execute it. So it's very simple, right? We got now the 3 months and the total sales of the current month. So now with that, we got the first information that we need in order to do the comparison. We have for each row the total sales for the current month. So now the next thing that we're gonna do is to find out the total sales for the previous month, like side by side in the same row. And in order to do that, we have learned we can go and use the lag function. So we're gonna go and integrate the lag window function in the same group by. So we're gonna do it like this. So lag, we are now interested in the previous month. So that's why we're gonna go and get the sum of sales as an expression inside it. And after that, we're gonna define the window. It's gonna be like this, over, and order by is a must. So we're gonna go and sort the data by the month, right? So let's go and do it. And with that, we have defined the previous month sales. So you are the previous month sales. So now let's go and execute it in order to see the results. Alright, so now let's check the results. The first row, what is the previous month? There is no previous month. We are at the first record and the first month. That's why we have null. Now let's go to February. What is the sales of the previous month from January? It is 105. So this is correct. And now to the last value, to the March, what is the sales of February, the previous month? It is 195. So with that, we got the two informations. We have the current month and as well the previous month. So guys, as you can see, it's magic, right? It's very simple. We can go and use the lead and lag functions in order to access another values from another rows without doing any complicated joins and so on. Okay, so now what is the next step? We're gonna go and subtract the total sales from the current month with the previous month. So in order to do that, we're gonna go and use a subquery like this. So select star from, and we're gonna have it like this as subquery. And now the calculation is very simple. Let me just move this a little bit down. So it is the current month subtracted from the previous month. And let's go and call it month over month change. So that's it. Let's go and execute this. So now let's go and check the results for the first month. You can see that we don't have any value, and that is correct because the previous month is empty, so there is no change. And now moving on to the February, you can see over here we got plus 90. That means we have here improvement in the performance of our sales. Now moving on to the last one, it's really bad. We have decline in our performance. We can see that we have minus 115. So that means the current month is doing really bad compared to the previous month. So the March is really bad month. Okay, so now as you can see in the output, we got the absolute numbers, but the task says find the percentage change. So we have to convert this to a percentage, and we can do it like this. It's very simple. Let's do it in a new column. Just gonna zoom out a little bit. So it's gonna be the change, the differences divided by the previous month's sales, and then let's go and multiply it with 100 in order to get the percentage. So like this, and now as you can see we got zeros, and that's because those numbers are integer. So we have to go and cast one of those values. Just gonna do it for the first. So cast, and you are float. So that's it. Let's go and execute it again. Now the result looks better. We have the percentages, but we have a lot of decimals. So let's go and round the number to, let's say, 1 decimal. So only 1, and let's give it a name. So you are month over month percentage. So Let's execute. So now as you can see, things get better, and with that we have calculated the percentage change in sales between the current and the previous month. And this is how we do month-over-month analysis. Alright, so now we have another use case for the lead and lag function. We can use them in order to do customer retention analysis. It's all about measuring the customer behavior and loyalty. So we are helping the business and decision makers to build strong relationship with the loyal customers and for them as well to focus on their needs. So now let's see how we can use lead and lag function in order to do customer retention analysis. So let's go. Alright, so now we have the following task, and it says, in order to analyze customer loyalty, rank customers based on the average days between their orders. So there is a lot of things going on over here. Let's do it step by step, and I would like always to start with a very simple select. So let's go select informations like the order ID. Let's get the customer ID, and as well, since we want the days, we would like to have the date. So order date from the table, sales orders, and let's go and sort the data. So order by customer ID and order dates. So that's it. Let's go and execute. So now as usual we got our 10 orders, the customers, and when they did order. So now let's check the task. Let's solve this over here. Days between their orders. So we have to find how many days are between two orders. For example, if we check the customer number 1 over here, he did order around 10 January. And the second order is like after 10 days, 20 January. So we have to go and subtract those two dates. Now, in order to subtract those informations and do calculations, we have to have everything in the same row. So for example, if we are at the first row over here, I would like to have as well one column about the next order. So the date of the next order. So we have to access a value from another row. Of course, we can go and do joins, but we have lead and lag functions. And for this scenario, we're going to go and use the lead window function. So let's go and do that. I'm going to go and call the order date over here as a current order, and let's go and calculate the lead. So I would like to get the next order date. So I would like to get this value over here in the same row. That's why this time we're going to get the order date. And now let's go and define the window. Now we have to go and partition the data because we are analyzing each customer separately, right? So that's why we have to partition that by the customer ID. And of course, in order to do the lead, we have to use the order by. So let's go and define that as well. Order by, and it's going to be by the order date. So now we have to give it a name. The order date here is the current order. This is going to be the next order. So next order. Let me zoom out a little bit and make this smaller. So let's go and execute it. So now as you can see in the output, we got a new column called next order. And with that, we got the current order, the current row, and as well the value from the next row. So what is the next row? It's going to be the 20 January. The same thing, of course, for the next row over here. We have the current order date and the next order date. So this value going to be exactly as the next one over here, 15th of February. And then since we are working with windows, this is the whole window over here. The last order for this customer, it's 15th of the February. There is no next order, so this is going to be null. The same thing, if you check the other customers, you can see always the last order don't have any next order. So looks like everything is fine. And for the last customer, he has only one order. So now with this, we got all the informations for our calculations. So we have the current order and the next order in the same row. Now we can go and subtract them in order to get the days between those two orders. And now in order to subtract date, we have to use the function dateDiff. Don't worry about those functions. We're going to explain all those stuff in the next chapters. So now just follow me with those steps. What we're going to do, we're going to go and subtract this date, the order date, with the whole thing over here, right? So the whole thing here is the next order. So let's do it in a new line. And it's going to be very simple. So dateDiff, we are finding the differences between two dates. So the syntax is going to be like this. First, we have to define what we are talking about. Are they days, months, years, and so on? So we have to tell SQL, find me the differences in days. Now we have to specify 2 days. So the first one going to be the order date. This is the current date. And the second date going to be the whole thing from here. So let's take it and put it side by side. And this calculation going to give us number of days. So we're gonna call this days until next order. Alright, so now let's go and execute the whole thing. So now let's check the result. As you can see over here, we got 10. So this is 10 days between those two dates, and the next one we have around 26 days. Here we have a null because we don't have here a date. And for the next one, we have 31 days. So we have a whole month over here. So everything is working perfectly. And with that, we have solved only this part. Days between their orders. So guys, you see, right? This is the magic of the lead and lag function. We can very easily access any information you need in the same row in order to do such an important analysis. And with very simple query, we are not doing any crazy stuff like joining and stuff. We are just specifying the lead function. So now we got all the informations that we need. Next, we're gonna go and calculate the average of those days. So in order to do that, we have to go and use a subquery. So let me just zoom out. So let's go and select star, just prepare the subquery. So the whole thing gonna be a subquery. I'm gonna just get rid of the order by, it's not now necessary. So let me just put it like this and shift it. So now what do we need? We need the average of the days. So we need the average of this value. So what can we do? We're gonna go and use a group by. So customer ID, since we have to find the average for each customers, and we're gonna get this value and say average days until the next order, and we're gonna call it average days. So, and we have here to group by, so group by customer ID. So like this, just make this a little bit smaller and zoom in here. So that's it. Now we are just doing a very simple average and group by statements. So let's go and execute it. Now, as you can see, SQL can go and aggregate the data. So we have now only 4 customers, and for each customer, we have the average days between their orders. So now what is missing in our task? If you check over here, it says rank the customers based on this average. So we have to go and use the rank function. So here again, another window function that we have to go and use. We're gonna do it together with the group by. So let me just make this a little bit smaller, and then let's do it over here. So I'm just gonna go with the rank function. Then we're gonna define the window like this over order by, and then we're gonna go and sort the data by the average days. So that means we're gonna go and get this calculation over here and put it as order by. It's gonna be ascending, so we are focusing on the lowest average days. So that's it. Let's call it rank average. So now let's go and execute this. So now by checking the result, you can see now we have a ranking for the average. And here SQL says that the number 1 customer, or the number 1 loyal customer, is the customer number 4, which is not really correct, because the number 4, we don't have a lot of information about this customer. He or she did order only once. So either now you go and like filter the data and remove this customer, where you say if the average is null, then don't put it in the rank, or we can go and replace this value with a very huge value in order to make it at the end of our list. For example, we can go over here and replace the null with qualisk like this, and we say if the average is null, then let's say give me a crazy number like this, very huge one. So that's it. Let's go and execute. And now as you can see, this customer gonna be at the end of our list. And now we can see that the most loyal customer is number 1. And then the other 2 customers are in the rank 2. Here we are sharing the same rank since we have the same average. So guys, with that, we have solved the task and we have ranked the customers based on the average days between their orders. So we have now a really nice rank, and we can understand now the behavior of the customers, and maybe we have to go and focus on the customer number 1 and understand her or her needs. And of course, the function that helped us here in order to do such a customer retention analysis is the lead function in order to find the next order to calculate the days. So this is how you use lead functions to do such a use case. The first value and the last value functions, I think the name says everything, right? So the first value can allow you to access a value from the first row within a window, where the last value, exactly the opposite, it can allow you to access a value from the last row within a window. Easy, right? So now let's understand how SQL execute those functions. Okay, so now as usual, we have this very simple example. We have the months and sales, and we have it twice because we would like now to go and compare side by side the 2 functions, first value and last value. So now for the left sides, we would like to get the sales of the first month, and on the right sides, we would like to get the sales of the last month. So now for the first task, we can go and use the first value. It's very simple. So the first value function, then the argument gonna be sales since we want the sales. And then the window gonna be defined like this, order by month, because we want to get the first month. So as usual, we must use order by. Now on the right side, in order to get the sales of the last month, we can go and use the last value, right? So the same things, last value sales over order by month. So as you can see on the left and right, we don't use any frame definition, but the default gonna be used from this. Alright, so now let's see how SQL gonna process both of those queries side by side. So the first step, SQL gonna go and sort the data. They are already sorted from the lowest to the highest. And then the next step is going to start row by row finding the first value on the left side. So what is the unbounded preceding? It's going to be static and always pointing to January. So this is always going to be the unbounded preceding. We have it in both sides like this. And what is the current row? It's going to be at the start, the first row. And on the right side, the same things over here. So the window definition gonna be is only one row, right? So what is the first value in this window? It is 20, right? The same things on the right side. What is the last value in this window? It is as well 20. So we will get exactly same results. Now let's move to the second row. So it's going to be pointing to February, and the frame definition going to be here extended like this. So what is the first value in this frame? It's going to be as well 20, right? So in the output, we're going to get 20. And now in the right side, the current row going to be as well pointing to February, and the window gonna go get extended. So now what is the last value of this frame? It's gonna be 10. Now let's keep going. We're gonna go to the March, and the window gonna get extended. What is the first value? It's always gonna be the same, so 20. On the right side, window gonna get extended. What is the last value? It's gonna be 30. So as you can see, the default definition is always having the static start, always the same start of the subset. And as we are moving with the current row, the frame gonna get extended. So now moving to the last one. And with that, we will get the whole dataset inside the frame. And the first sale is gonna be 20. On the right side, the same things gonna get extended like this. And this time, the last one gonna be April and 5. So now if you go and compare them side by side, you see that on the left side, the task is solved and everything is working correctly, right? So we have for each row always the sales of the first row. And what is the first row? It is January. So we have everywhere a 20, which is correct. But now if you check the right side, you can see there is something wrong, right? We are getting not the last value. We should always get April, right? We should have here everywhere a 5. So we have here exactly the same result as the sales. So it's really useless to use it like this, right? And that's of course because SQL is using the default definition of the window frame. Last value is the only function from all window functions that you cannot use the default frame definition. You have to go and customize the frame definition in order to get the effect of the last value. For the first value, everything is working if you are using a default frame, if you are not specifying anything. But for the last value, you will not get the effect correctly without customizing the frame window. So my friends, you can go and use the first value function like all other window functions without defining a frame. You can go with the default and you will get the effect of the first value, but the last value you have to go and define a frame. So let's see how we can solve that. Alright, so now in order to solve this, we're gonna define the frame like this. It's gonna be the rows between the current row and the unbounded following. So we just switch things around. So now let's see how this is gonna work. Now of course, SQL gonna go and sort the data and so on. Now SQL gonna have a pointer to the unbounded following, so it's gonna point always to the last row in our dataset, and then it's gonna proceed step by step. So the first row gonna be like this, and the frame gonna be the whole thing, right? So from the current row until the unbounded following. So what is the last value? The last row, it's gonna be the 5, right? The April. So we will get in the output 5. Now let's proceed to the next value. The frame gonna be shorter and smaller. And what is the last value? It's gonna be as well the 5, right? So now we jump to the next one, and the frame gonna be like this. What is the last value? As well 5. And then we will get the last value like this. Current row is equal to the unbounded following. We have only one row and it's going to be as well 5. So as you can see, it's very simple. Just fix the frame clause and you will get the last value working as expected. So this is how SQL going to go and do it. Now let's go back to SQL and start practicing. Alright, so now we have the following task. It says, find the lowest and highest sales for each product. So now let's see how we can do this. As usual, we're going to start with very simple select statements. So select order ID. We need the product ID and as well their sales. So let's select the table, sales orders. So that's it. Let's go and select this. Now in the output, we got our orders, product, and sales. So now let's start with the first part of the task, find the lowest sales for each product. So in order to do that, we can use the first value function. So let's go and do that. First value. Then what we are talking about, we have to give an expression. We need the lowest and highest sales. So let's go and have the sales inside it. And now we have to define the window. So over, since we are saying for each product, that means we have to go and make windows. So we have to divide the data using partition by product ID. And then we must use an order by, right? So we have to go and sort the data by the sales. Since the first value should be the lowest value, we have to do it as ascending from the lowest sales to the highest sales. So we're just gonna leave it like this as a default, and we're gonna call it lowest sales. So let's go and execute this. So now let's go and check our results. First, SQL gonna go and partition the data by the product ID. So as you can see, we got now here 4 windows, then sort the data by the sales. So the data are sorted from the lowest to the highest, from 10 to 90. So now what is the first value of the sales? It is the first row, right? So it's gonna be 10. That's why we have everywhere a 10. Let's check another one. Let's take this one here. So this window has 2 rows and it is sorted. The lowest sales, or let's say the first value, is 25. So with that, we have solved the first part of the task, finding the lowest sales for each product. Let's go to the next one. We have to find out the highest sales for each product. So let's go and use the last value for this. So let's have a new line. We're gonna have a last value. Again, the sales. Then we're gonna go and define the window. So it's gonna be the exact same window. We have to partition the data by the product ID and order the data by sales. So let's go and just copy the previous one. Let's call it for now highest sales. So let's go and execute it. So now if you check the results, you will see our issue over here again, right? We are not getting the highest sales for this window. The highest sales is 90, but as you can see, we are getting the exact same sales, and we have explained that in the previous example. So in order to fix this, we're gonna go and add for it the frame. So rows between current row and the unbounded following. So now let's go and execute this. So now let's check the result. As you can see over here, we got the highest sales correctly. So for this window, the highest one is 90. And as well for this window, the 60, and so on. So with that, we have solved both of the tasks, the lowest and the highest sales. But now I would like to show you my honest opinion about these tasks. I will not go and use the last value to find the highest sales. So let me show you how I usually do it. I'm gonna go and use the first value in order to find the last value. So now let me show you what I mean. Let's go and add a new row. I will just take the whole thing from the lowest sales. But what I'm gonna do, I'm just gonna go and change the order. So that means we will not go and sort the data like this, ascending from the lowest sales to the highest sales. We're gonna go and switch it. So we're gonna go and sort the data from the highest sales to the lowest sales. And with that, the first value gonna be the highest sales. So let me just rename it. Highest sales, let's give it like 2. So let's go and execute this. And now you can see over here, we got the exact same results because we sorted the data differently and we get the first value. So this is gonna give you the exact same effect like the last value. And as you can see, I don't have to define now any window or something like that. I can stick with the default frame, but just twisting the order by. So this is how you can do it as well, using only the first value. So now just for the sake of this task, there's as well another possibility in how to solve this. You can go and use the min-max functions. So let me just take the same and have a new one, the lowest sales. We can go and say, you know what, let's get the min. So we are saying, find me the minimum sales, and we don't have to go and sort anything. So we can go and just divide it like this. So let's give it another ID. Let's go and execute it. So as you can see, we got the exact same results like the other 2 highest sales. So as you can see, we can solve this task using 3 different functions. Either go and use the last value, but you have to define the frame, or you can go and use the first value where you switch or flip the order by, or simply just using the max function in order to get the highest sales. So guys, as you can see, we can use the first value and the last value in order to find out the extremes, like here in this example, the lowest and the highest sales. So there is like similarity between those two functions and as well the min and max. And of course, what we're gonna do with this value over here, we can go and compare it with the current sales. So for example, we can go and extend our task where we say find the difference in sales between the current and the lowest sales. So in order to do that, let me just clean up all those stuff. Let's stick with the first value and the highest value like this. So we have to compare now the current sales, which is this field over here, the sales, the original one, with the lowest sales, with the whole thing from here. So let's go and do that. So we're gonna have a new line and we're gonna say just simply subtract the sales from the lowest sales. So like this, and let's give it a name, sales difference. So that's it. Let's go and execute it. Now, as you can see in the result, in one row, I'm comparing the current sales, which is 90, with the lowest sales from this product. It's going to be the 10. So with that, we're going to get the distance, let's say, between those two informations, and it's going to be 80. So now for the next one, the distance between this value and the lowest value is shorter. So we are near the lowest value. So as you can see over here, we can now compare the sales between the current sales and one extreme in order to find the distances between two values. So this is again a very important analysis in order to do comparison analysis. Alright friends, so now let's do a quick recap about the value functions, or we call them sometimes analytical functions. So what they do, they're gonna go and allow you to access a specific value from another row. This is gonna help you in order to do complex calculations with very simple SQL without having you joining tables together or doing self-joins. And for the value functions, we have 4 types, or let's say 4 functions. The first one allows you to access the previous value, like the previous month, using the lag function. The next one, it allows you to access the next values, the next month, using the lead function. Then we have another one, it allows you to access the first value in a subset using the first value function. And another option, we can go and access the last value in a subset using the last value function. Moving on to the next one, we have the rules of the syntax. So about the first point, it is the expressions. We can go and use any data type. It could be a number, string, a date, anything. Now, in order to perform those functions, we have to go and sort the data by the order by. So order by is required, it is a must. Then for the frame, you are allowed to use it, so it is an optional thing. I would say always leave it empty for the frame, but only for the last value you have to go and customize, otherwise it will not work. Now to the next point, we have the use cases. We have simply very important use cases for the value functions in data analytics. So what we can do time series analysis. As we learned, we can do month-over-month analysis and year-over-year analysis. Those analyses are classical, and it's always the first question in data analysis in order to measure, are we growing with the business or are we declining? How the performance between the current year and the previous year. So as you can see, we are doing always comparison using those window functions. The next use case is as well about the time. We can do time gap analysis as we analyzed the customer behavior, the customer retention, where we have calculated the average days between 2 orders. And the last use case, it's as well about comparison analysis. We can go and use the value functions in order to compare the current value with extreme, like comparing the current sales with the highest sales or to the lowest sales. So my friends, those analyses are essential in data analysis. You will be countering them in each company, in each business. You have to answer those questions, and you can do that very easily using the SQL window functions. Hey friends, so finally we have covered everything about the SQL window functions and their amazing use cases for data analysis. I promise you, you're gonna use those functions in real projects. If you like this video and you want me to create more content like this, I'm gonna really appreciate it if you support the channel by subscribing, liking, sharing, commenting. All those stuff gonna help the channel with the YouTube algorithm, and as well my content gonna reach the others. So thank you so much for watching, and I will see you in the next tutorial. Bye.